Jesse, welcome back. We
Welcome
are here
back,
for
Sean.
day 2 of 3D Experience World, and we've moved.
We have moved.
We've moved the
well,
entire...
slightly.
Yeah, slightly. We will discuss why we are at a different desk right now. We have some special guests to get to in just a moment. But firstly, I want to thank you all for tuning into the stream. You know you can't count on, even though this is the second day, the big focus is tech updates with some very special people. You can't count on the idea that the same people that watched the first day are watching on the second day. We have, I'm sure, a lot of new audience members due to the content that we're going to be showing today, particularly within general session, I'm sure. But once again, we have a lot of great guests. Jesse, how you feeling? Day
I feel
2 of
great.
the conference?
Yeah, I'm bright-eyed, bushy-tailed. How about you, Sean?
Me too. So with that said, a lot of you may be new watching this conference, maybe the first time you've ever been exposed to 3D Experience World. So before we get to some special guests and all the great content that we have in store for you today, I just want to show my screen here just to give you an insight into what this conference even is. Oh man, this thumbnail is doing a lot of work, right? So shout out to Ian Adair for making this thumbnail. But yeah, today is going to be largely focused on tech updates inside the Solidworks ecosystem and, of course, well beyond. But this conference, primarily 3D Experience World, it is a user conference, right? Designers, engineers, manufacturers, students, you name it, right? So makers, content creators, the list goes on and on. We have around 4,000 people here on site for 3D Experience World, and it feels like it.
It does.
Right?
Yeah, we didn't get probably a great shot yesterday of the whole hallway packing in for a general session, but we definitely got it when we were in the playground. It was tight in there. Right? We were trying to weasel our way through, as we do every year, trying to show you what's great at the conference, but it is always bustling in there.
Yeah, and I mentioned it is a user conference. This is not a sales conference or a marketing conference. This is a user conference for all of you out there, industry users, maker users, and a lot of first-time attendees. So you're thinking, I've never been to a 3D Experience World. It seems like everyone there, they have these long, elaborate badges, right? You know, it seems like they know everyone already. Sean and Jesse know everyone already. That's not true. We had 400 people, and again, it felt like 400 people at the First Timers event on Sunday. So if you're thinking about traveling out to a 3D Experience World next year, first of all, we'd love to have you. But we have a lot of first timers, a lot of second timers, repeat attendees, some people, of course, who have been here for 10, 15 years. This conference has been going on for a long time, but it continues to evolve. So thank you for all of you who have ever attended 3D Experience World. And again, hope to see you again soon. 270 hours of conference. That means SOLIDWORKS design content. For those of you who are SOLIDWORKS users, SOLIDWORKS PDM, SOLIDWORKS simulation, real industry workflows as well. It's not just like, you know, product webinar kind of stuff. Stuff you can only get in the room. Like we had a tech session here at the desk yesterday.
We did, yeah.
And the session was largely, like I always tell people, if you're at 3D Experience World, it is a one-time session, right? You can think, I can get the content online. No, not really, because you'll never have that same audience with that same combined expertise contributing to the overall health of the session.
Yeah,
right?
Anytime I used to do a session, that was always my favorite part. Once you get to the questions at the end, right, that's when the session really comes alive.
Yeah, and yesterday we had, and this is a plug for day 1. It tends to be one of our most popular streams. I think we've already broken the record for the first like 24 hours after day 1's been published. But
thank you to
in
you
terms
guys.
of visibility, yeah, thank you for tuning in. You can still watch all of day 1's events. If you're looking to get like just a look at what 3D Experience World is, you know, at its heart, you know, everything, tech sessions, general session, all the announcements that were made there, and there were many, you can still tune in to day 1 on replay on the SOLIDWORKS YouTube channel.
Yeah, Sean, you talked about people, you know, coming back for a second time, maybe yesterday, and repeats. Every year we say the same thing. It's like a family reunion, right? Once you come once, it's like, well, I have to come every year now, right?
Right.
It's one of those things where you just, once you experience it, you always come back. Of course, this feed is always one of our goals is to try to encourage you guys to come. We'd love to see you. Obviously, 400 newcomers, as you just said, this year, but then just keep recycling. Obviously, we got to this because we love our software, but
sure.
Every time somebody's asked why they stay at this company, it's always the people, right? Tyler said it too. With this conference, it's the people. Come for the software, stay for the people. Definitely true of this event.
Exactly, and speaking of, you know, hundreds of sessions, you might be thinking, oh, it's just hardcore. Yeah, we have hands-on sessions where you're doing picks and clicks. We have lecture-based sessions, industry workflow sessions led by a lot of our customers like you guys. But we also have meetups. A lot of different types of environments that you can put yourself into so you can make connections that last beyond the conference.
Going to one tonight?
Yeah. Yep, tonight, special event, NASA Space Center. Man, I can't wait.
I was going to say a meetup, but also special event.
Quite a lot going on here.
Yeah.
All right, so once again, just wanted to spend the first 5 minutes just educating you guys on all the goodness that's going on here. Of course, we have a lot on the broadcast specifically for you today, but I want to switch gears a little bit. So as many of you may know, SolidWorks recently celebrated 30 years. 30 years of SolidWorks, 30 years with all of you. Thank you for being a part of that whenever you joined us. And we thought, specifically our next guest thought, that a design competition with a tie-in to World, 3D Experience World, seemed like the perfect idea. So with that said,
I agree.
Yeah, wanted to introduce our guest, and that's why we are at a different desk right now. We have a jam-packed desk A. Welcome to all of you. Thank you for joining us. We'll get a chance, of course, to introduce you. But first, Anna, I wanted to ask you and Kamal, once again, SolidWorks turned 30 last year. We celebrated it in so many ways, large and small, right? We had so many LinkedIn posts, social media posts, events, all that. Swag-in, right? Many of you were involved in Swag-in as well. But why was a design competition the perfect way to celebrate?
It started a year ago here in Austin. We had a meeting with GP, and we just proposed him, to have a tour in Europe, to celebrate these 30 years of Solidworks, and at the same time, to organize a big contest with all of our passionate Solidworks users, and that's why we are here today with the 3 champions.
Nice, awesome. And so could you explain a little bit more about the sort of the contest? Like how did it go? Was there like a jury? Who was the jury? How did this work?
So the first thing we did is looking for the right jury to make sure it was an external jury. So we went and we spoke to Kirby. We worked with Dan Wagner, our leader of the SWAG community over here, and we found others. So we had like 5 members of jury. And that enabled us to make the contest. So the contest was something very tricky because we did that in LinkedIn. So we had to ask them to share their assets first, and then create a video time lapse and share it in LinkedIn. So the more liked they have in LinkedIn, they were able to be, one of the 30 finalists. And after that, we had the jury who selected the 3 winners and the 4th finalist as well.
Okay, so you guys at home must be wondering, or at your office, for everybody watching, those of you watching as well in the attendance here, you're talking about a design competition, 3D models. I haven't seen any 3D models. So let's actually look at my LinkedIn feed here. I'm logged in. I probably have some requests that I need to tend to.
Is that why you've not been responding to me?
Yeah. So, okay. So you actually have some video clips I think we can share as we go. If we look at those here. So let's get into some of the models here. So we have Samuel's helicopter transmission, which is awesome. I love the rendering and animation. And by the way, on LinkedIn, I had like 7.5 million impressions, tons of engagements, reshares.
Why.
Yeah. So the SolidWorks reach is real. It's way more than I probably could have gotten on my own LinkedIn, by the way. We have Adi's modern tractor concept. So if we could show Adi's submission. Adi, I've been following you on LinkedIn for so long. It's a pleasure to actually meet you. You're always busy at 3D Experience World. You're in high demand. This is a beautiful 3D model, as well as Madi's prosthetic knee. So these are all examples of models that are beautiful, are complex, expertly created, but very different. So all of these made it to the finals. So that once again, these are very wildly different projects. They all made it to the finals. But my question is not about what makes them different, but what they might have in common. So what do these finalist submissions have in common?
Passion.
Passion.
Passion. I mean, and a big network, because obviously they had a lot of likes. So we were able to really, make this viral. So that was impressive. And I would, love to hear from them. But, it was for me a first contest, and I really liked it because it was really passionate and a lot of energy.
Absolutely. So as we hear from you guys, Samuel, Adi, and Madi, what part of your design pushed SolidWorks the hardest? Right? What would you say in terms of making this model? What were the things that went into it? Just talk a bit about your models if you could.
I honestly think the hardest thing was the animation. to get that working. And the great thing with Solidworks is you can just export motion studies. So you can just set up the mates in the assembly, export that into a motion study, export to visualize, and then it's really not that much work. It looks a lot more complicated than it actually is.
So let's take.
My ears.
I think my LinkedIn is actually loaded here. Sorry. So let's take a look at the LinkedIn because I have your actual LinkedIn post here. All right. So once again, I have some notifications I have to get to. You can see. Don't judge me. But you can say, okay, so as part of a school project, I was tasked with designing a complete helicopter transmission using SolidWorks. So this is awesome. You can see I celebrated it. I reacted. There's proof. But this is great. Look at that. You have like 1,400 engagements, tons of comments, tons of engagement, tons of reposts, just people appreciating both your knowledge, but also I'm sure inquiring about the things that you've done, been able to do in SolidWorks, and also beyond just the CAD level, but an engineering level. So this is awesome. So moving on to Abdel, if you could talk about your model, your 3D model.
My 3D model is a prosthetic project.
So Abdel is from Tunisia, so
Yeah.
we'll be helping him talking. So start if you want. Tell me.
Je parle de.
Dites ce que vous voulez dire en français.
En français, oui,
Oui,
je parle du projet.
Yes.
Alors, le projet, c'est une prothèse bionique qui permet de supporter une charge de 250 kg avec une articulation de 120 degrés. Et la particularité, c'est qu'elle est adaptable à tout le monde. Voilà.
Okay. It's what you can see on the screen. I mean, it's a prosthetic,
Prosthetic.
and it's very light, and it does many things. I mean, it rotates. I cannot explain everything because I don't have the the English vocabulary. But have a look, and you will see.
And this one can be used by everyone.
Yeah, and it also we saw just a moment ago. Yeah, we have some animation in the background here. Great video, so you can see some of the motion. We had some earlier clips of it mobile, which is great. So let's move on to Adi. So tell us about your 3D model.
But when we talk about my 3D model, that was the AI tractor that I've designed for last year. That project was for AMD and HP companies. I'm working for AMD from 2018. And every year I prepare the new model. This year we have a truck. The biggest problem I always have, it's not about the SolidWorks, it's about the time, because I have a few months to build something like this, and that is for me the biggest problem. But I enjoy working in SolidWorks. It's not a problem, it's easy, it's user-friendly. I'm doing a lot of education. That is why I always explain to students it's not hard to use SolidWorks. So I'm using it, building stuff in that, but biggest problem is time, because you always don't have time.
That is an ambitious project for a couple of months.
Yeah.
Yeah, and I made sure to like some of yours, give the heart emoji for some of yours, share that I felt that it was insightful, and I agree with all those things. I truly mean them. So this is great, Dr. Pax, of course. That's how I found you. I found you on LinkedIn. I was like, who is this guy? He's the best models. I could never do this in SolidWorks.
And renderings, let's not forget.
So I wanted to, Anna, and Kamal, come back to you. Tell us about, and excuse me if I'm mispronouncing this, but Ubang Umoran, one of your winners from Nigeria who couldn't make it here to Houston.
I think I'm going to leave our friend
Kirby.
So yeah, I was one of the jury members, and I just want to say that going through all of these designs and that was truly inspirational and amazing. Each of you guys were solving a different problem. I mean, Adi, yours is very conceptual. And Samuel, yours is very mechanical and shows of what you can get away from SolidWorks. And the prosthetic leg is solving a problem with someone with limb difference. And it's the same thing with Ubang, the winner from Nigeria. His project was solving a problem solely based in Nigeria. So it was really great to see it. And unfortunately, he couldn't make it. And we really hope to see him next year.
Kirby, I'm always so happy to see you.
I'm happy to see you, Sean.
But as part of this competition, we were able to bring you guys to 3D Experience World. This is amazing, and of course, it facilitated further connection that will spare us into the next 30 years, right?
Yes.
Oh, look at that! That's awesome. I need some of that swag. I need to get one of those T-shirts.
I will give you one.
I'm a medium.
Thank you. It was
Well,
great.
awesome. Thank you all so much for coming here to the desk, for being here at 3D Experience Show,
Yeah.
for all the
Thank
work that
you,
you do. We're going to be back in just a moment with some special for live only design reviews with some designs that move people. We'll be right back.
Well, we're back at the main desk, and regardless of what it is you're designing, could be a consumer product or an experience, we're always aiming to design things that move people.
Physically or emotionally?
Physically or emotionally, right? We look to be moved. Now, there's a lot of emotion here at this conference. There is also a lot of really cool tech. And this segment, we're going to get into showing off a few of our customers that are here and displaying some pretty cool things that we'd like to share with you. So we've got a lineup in our design reviews, Sean. We've got a lineup here of a few customers we'd like to highlight. Sitting next to us, Barrels of Fun. Howdy. Guys, your name is pretty appropriate for the kind of products that you make. You chose wisely in setting that up. Welcome, guys. Thanks for coming on the show.
Thank you for having us.
Yeah, we're looking to kind of dig into the nuts and bolts of both your products, your processes in these segments, and well, have a bit of fun with it, which is going to be easy with you guys.
Well, and I think it's funny that you brought up experience and emotion. And what we make, which are pinball machines, I think really encompasses that. We always look to try, and the whole point of a pinball is an experience.
Yeah.
So how do we engage our customers? And that goes into choosing what licenses that we want to use, what stories we want to tell. Because what we really do create, it's not just a ball that goes around. We are creating a world under glass. So it's like, how do we get our customers interact with that on a personal level?
Yeah, and that's interesting. I think a lot of products are aiming to tell a story one way or another. You guys are literally telling a story, maybe a shared story with something that already exists, right?
Yeah.
And people at home are probably jealous. People who are watching at their office, they're probably jealous. And we're going to start to see some actual video footage from your YouTube channel, just to give an idea. I believe this is the Labyrinth machine.
Yep. Our very first game.
Which is in the playground.
Yep.
As well as the Doom machine, which we'll talk about. But we talked about moving people emotionally, right? And when it comes to a movie like Labyrinth, you guys have talked about this. I think I watched an interview with you guys and Adam Savage. It is a cult classic movie, right?
Yeah.
Has a lot of lore, a lot of, and so there's an opportunity for a lot of detail, right? Almost like storytelling of the machine in terms of moving people. So how do you translate that nostalgia and that fandom into both the aesthetic and the sort of mechanical feel of a machine like that?
So with Labyrinth, well, how I task our team to do a design is like, we don't get technical first. And I also don't want to do a deep analysis of whatever IP or story that we're going to do. So typically we'll have a blue sky opportunity where we'll go, this is what we're working, for example, Labyrinth, I'll use an example. What are 10 things that you remember from watching the movie? A couple of our people said never seen it.
I love that.
The other ones, and I don't want them to sit there and analyze it. What are 10 things you can quickly think of what your memory is, okay? So what we found is people remember Elo the worm, okay? And then they think of the knockers. They think about Ludo in the house. They think about the castle. And when we got those 10 things out of everything, there's usually 5 core things that everyone remembers. So we try and base all our ideas and toys and mechs are going to be fun around those elements, because typically what you find, if that's the common area that people are remembering, that's what we need to focus on. Because what we're trying to do here is tell the story of the license of the movie or TV show or a band, but also have that connect to a pinball. So we're trying to converge the pinball player and the IP fan and cross them over where they can get to experience pinball like they've never had before, but also expose pinball people to an IP that they've never ever seen before.
Now, as far as licensing goes, how does that, you don't have to say any secret sauce, but I'm sure it works differently in many cases, but do you find that your designs are driven by the people who are you're licensing from?
Story first, every time.
Yeah, okay.
Story first. So that we want to work with licenses that understand that we're trying to, we're honored to be given these opportunities to basically carry the torch for them. So we want to work with licenses that understand we're trying to make this the pinnacle of their fandom. So that's what we look for in a partner. It's not just about money. I mean, it has to make financial sense.
Sure.
But it's about how can we tell the best story on this canvas, which we choose to be pinball.
Yeah, and if we could show just in the background just another example, we have some footage from the Dune machine that you guys had created. But I want to get into some of the design elements. Not everyone is a pinball player. Some of us are. Like we had our certified Solidworks expert event at an arcade last night. An odd amount of certified SolidWorks experts here. Usually you don't have that. That's like the highest certification you get as a SolidWorks user. And of course, there's a lot of pinball played. But when you think about, a lot of us watching, we are SolidWorks design users. We're using CAD a lot. What is something that maybe a non-pinball user might not immediately think about when it comes to things about the design that you really just can't get wrong, or else the machine's just not going to be playable, or it's not going to be good, or any of that?
So you gotta remember, I'm not a SolidWorks user. I'm not a CAD designer. I'm a guy that worked in film and TV for 25 years. And I got this little thing in my head that I wanted to build a game. So Labyrinth, for example, that was built in my dining room. Like that was using Illustrator, like very traditional.
You were telling me that.
Making that, like just with cardboard and sending stuff off to Sendcart Sand, getting it bent and start putting it together,
awesome.
right? However, what I realized, like if we're going to make this true, like you can make a 1 or 10 games, but for production, like you got to have a set structure to make that happen.
Yeah.
And that's when I hired Paul, who basically took what I had in my dining room, put that into SolidWorks, and that's when we started to realize, oh wow, this can't happen because this is going to catch this and that, which you can't see in the physical. But I'll turn this over to Luke here. Like, there's also things when you're designing in SolidWorks you can't even see. Like, when you're working in SolidWorks, that hole looks so big.
Yeah.
And
Yeah,
until
you can zoom in.
put it
Like
on the
Luke
real
knows,
thing,
like you can zoom in as much as you want. You can make the hole as big
I
as
think
the
it'll be
conference center.
miles long, yeah.
yeah, and like, for example, like, so I don't use SolidWorks, but I knew the importance of getting it into production. However, like, I look for people that want to make stuff. So a good example is Luke here. He's a junior prototype engineer. His background is electrical engineering, but he made a whole pinball machine on his own.
Wow.
So as soon as I saw that, I was like, dude, you need to come and work for us. But you want to talk about the SolidWorks side of what they were talking
Yeah,
about?
I'll go ahead. And I'd say the most important thing that you can't get wrong, that you wouldn't really think about, is like the geometry.
Yeah.
And like the way that the shots flow. If the game doesn't like shoot well when you play it, it's not going to feel fun. And I think it kind of looks like you kind of can put shots like wherever you want, but it's really tight. The way that everything lines up together needs, like the geometry is really important to get right, so that the ball doesn't like rattle in between the shots. Because if you're not getting flow while you're playing, you're not going to be able to sort of interact with the world under glass, like David was saying.
So how do you, which comes first? Do you set it up statically, just kind of aesthetically, the way you think you might like it to work, and then go from there and see how that dynamically works, or and just kind of iterate in that way? Or?
I drive him crazy because I'll have like a napkin drawing of like, okay, this is like we'll have our ideas and we'll go, okay, well this could be here, this could be there and there, and then we're like, all right, well, see if you can throw that into SolidWorks. But he's also been using virtual pin as well.
Yeah. So virtual pinball helps you get the first like 10 iterations that you might use like cutting in plywood, and that gets you out of the way. The physics like isn't perfect, but you can kind of test your crazy ideas and like, is this even feasible at all?
Yeah.
And you can sort of get an idea of how your game might flow virtually before you have to start getting to wood. And it's a lot faster to lay out, your ball guides and your ramps on your computer and shoot it there than have to like fabricate it and like test it in real life.
And the biggest thing I try to tell the engineers is like, just try it. There's a lot of rigid like, oh, well, that's not going to work. It's like, well, have we shot it? And it's like, just shoot it. Like, there's many times like, that worked better than I thought. And it's just like, you just got to keep making. And that's what's important. You can't just sit behind the desk and design something. You've got to get out there in the practical world.
Feel attacked.
That's great. Great advice. Great advice for any industry, right? Just try it.
You got to do it.
Right.
So how do you guys design, like we were talking, we had the CSWE event last night, you have your pinball machines in there, you have competitions I'm sure are happening around the world, maybe using your machines. Like, these machines seem to get abused.
Very much.
Nudging them, slamming them, right? It's a very like physical game, right? In terms of designs that move people. People are moving the crap out of these machines. So how do you design for that? Like I know like you're trying to look for continuous flow, but in terms of rigidity and making sure that the machine will kind of last.
Well, it's funny because here at this convention, the engineers are actually all very nice to the machines, I'd say. But
You're almost like egging them on, like, no, you can do more.
shake it.
Yeah, you can shake it.
Like, is there anything you can do when it goes in the middle? I'm like, yeah, hit the machine. So I'd say you can't really avoid people like shaking the game. You even give them, like you allow them to do that. You get 3 tilt warnings. So you can even do it twice without getting a penalty. So there's no way to really prevent the player from doing it, considering you really allow them to do it. I guess one thing you can do is try to avoid like shots that would force them to do it to keep playing.
Okay.
Obviously it's going to happen randomly, but you really want to make sure that you're not, I guess, abusing the player more than you have to on the game.
And we'll even taunt them. Like, so as you talk about, you got 3 tilts. And there'll be moments like, you shouldn't be doing that, you know? And then it's like, oh, you're getting close. And then, like, for example, on Labyrinth, the ball will drain out and one of the fireways will pop out and go, catch you later. You know, it's just
That's
like,
so cool.
Our goal is to try and tell that story in 3 minutes.
Okay.
So how do we get them to interact with all the different parts? But however you get there is the question of, you know, how do we get them to move the machine or get them to do things that teaches them how to play the game, but also get to experience all the elements on that. And that involves moving the machine, that involves a lot. And we test our games very thoroughly. So pinball machines break. Like, there's no pinball machine in the world that I've ever come across. You move it halfway across the room, there's something that needs to be a little bit fixed on it. I mean, we're using electrical, mechanical, like, there's so many moving parts in there that you can't account for. But we do test cycles on our games before they go into production and stuff like that, because these go out all over the world.
How satisfying is it to make something that's really just its only purpose is to give people joy? Like, it's got to be so fun to build it and then just watch people interact with it.
So I'll give you a negative and a positive.
Okay.
We made Jim Henson's Labyrinth, which is a very kid-friendly game. But when we built that in a kind of closed environment with very high-end players, so I was super excited to get that into the world. But because we were designing it to high-end players, when I saw kids walk up to the first time, the game just drained on them. Like, it was just brutal. And I just like, oh my goodness. Like, I made, like, this is games that kids want to play, and they just don't know what they're doing.
Yeah.
But to see their bowl drain and they get teased by the little fiery popping out, and because typically when you drain, you see most people get upset. But on the same token, when they get taunted and they see a little toy pop out, they want to hit that start button again. And seeing people hit that start button again is like the best feeling in the world, because you've connected with them. They either knew what Labyrinth was and they discovered pinball, or people that saw pinball didn't care about Labyrinth, but when they played it and they connected to it, and they're, oh wow, this is one of my favorite games. Like, we've experienced that with Dune. Like, a lot of pinball people that did not know what Dune was. And now we're getting emails and phone calls. It's like, my son or daughter had no interest in Dune. Now they've got the game, they've read both books, and they're waiting for part 3 to come out.
Oh, that's cool.
And like, they didn't have anything to do with Dune, but now they connected it through pinball, and we're seeing it the opposite way. So that's the reward for me. What about you?
I don't know where to start. I mean, I don't think the point of pinball is to really get where you're trying to get on your first go. I think what it really should invite you to like want to get further in the game. And so what I think is really fun is like people, you can see what the game might have to offer. For like on Dune, you can see that there's like a sandworm mech. And I had a lot of people ask me yesterday, like, oh, what do I have to do to see that move? And so, and you know, they might not get there on their first try, but they would just keep going and going until they would get to like the multi-ball, where they get to that big, I think we call it like pinball moments, where you get to see the sandworm go and like see like the animations go and the music and all the lights. And I think it's really fun to watch people experience those pinball moments, I'd say.
That's awesome. Guys, I could talk to you forever.
I know.
If you're watching here in person, you can go check out Barrels of Fun in the playground, just steps away. But if you're watching at home, barrelsoffun.com. David and Luke, thank you so much for jumping on.
Thank you
for having us.
All right, so we'll be back in just a moment with Dr. Zhang and Westwood Robotics. We'll be right back. Stay tuned. Okay, we are back at the live desk. We continue on with our design reviews session. We have so many interesting customers with designs that move people both physically and emotionally. And you can take that in so many different senses, so many different industries, so many different lanes. So we are back with Dr. Huang from Westwood Robotics. How's it going?
Good, good. Thanks for having me, Sean.
Absolutely, absolutely. So you have a mission to bring robots closer to people. That's movement. Like that's definitely movement.
Yeah.
So, and it's a bold statement, right? So how does that sort of impact your design decisions overall, knowing that you'll be, making robots that are meant to be around people?
Yeah, so I take design from two aspects. One is aesthetic. The second one would be functionality. For aesthetic, let's talk about that first. Especially for our full-size humanoid robot, Siemens, it's a robot that's meant to be a teammate for people, to work around people, but not intimidate people. So we design it such that it's in a human shape because it's required by functionality, but it looks like a robot. You exactly look like a robot. So people know that, okay, that's a friendly robot that is doing its job consistently, reliably, and I'm good with her, with the robot every day, and it's not going to scare me. So people feel good about it, having it around. So on the other side, I mentioned that design is also about functionality, and we can also look at Bruce. It's a really good example of, all about functionality, really. We designed this robot so that it's lightweight, easy to fix, and open source, easy to play with. So we designed it so that it's following the only principle that it gotta be modular, it gotta be easy to play with, it gotta be lightweight. So yeah, that's like about functionality.
It's interesting you say aesthetics because you came up and set this down and something about machined aluminum, anodized, and carbon fiber together just looks so good. I was like, oh man, the aesthetics of that are beautiful. So it's interesting to hear you say that that is a focus as well. Oh yeah, we got a close-up on it now too. It is a beautifully put together device.
Very nice, yeah. And I'll get to Bruce. I don't want Bruce to think that I'm just ignoring him. But I want to talk about your larger robot, which is in the playground. Of course, you saw it. We see it's handling, I believe, waste in this context here.
Yes.
But with Themis, am I pronouncing it correctly?
Themis.
So with Themis overall, to speak to Themis, obviously we see Themis operating in a human context, but it may operate in multiple contexts. So how does that affect maybe the configurability or the programming of the robot, knowing that the context may change?
Okay, so that's actually a question about software I'll take. So we recently announced our 2.5 generation along with our AI augmented humanoid OS.
Oh, interesting.
That's like operation system with a modular stack of whole body stability, navigation, and a safe interaction with consistent behavior. And the AI underneath the whole thing is capable of basically learning new tasks or new environment with minimal data. For example, a couple photos or a short human demonstration, and then the robot is all set for that job.
Wow, that's way different than what I would have expected like 2 years ago or 3 years ago. Like we are seriously living in the future in a lot of ways. But I mentioned I don't want to ignore Bruce here, so let's shift to Bruce so we can talk to Bruce. You have a design here. I want to ask, just first of all, why was Bruce created? Like, is Bruce just a mini Themis, or does Bruce have different applications?
If you're looking at a timeline, Bruce is like the old brother of Siemens.
Oh, okay.
So we created Bruce back in 2016, 2015-ish. That was a long time ago.
Okay.
It was actually my PhD project.
Interesting.
Back then, 2015, humanoid robots are heavy, expensive, dangerous to work with them. They're easily like 100 grand or something, or even like, really 200 grams easily. And they're like 200 pounds or 300 pounds. And just imagine like a 300-pound thing just leave their arm and smash into her face. That's really dangerous.
Yeah.
So, as a PhD in robotics, I suffer from it. I believe everyone in my field suffered from it. So the idea was, what if we could build a humanoid robot that uses the most recent technology, most recent control algorithm, design philosophy, and then but it's super lightweight, and super easy to work with. We were so intimidated about a robot being broken. 300 pounds and it falls. Sure. We think nothing but catching it. But this guy, you don't worry about that.
I was going to say, I mean, maybe you can lift 300 pounds. I'm not sure, but you carried it over pretty easily.
Yeah, this is like 5 kilograms with battery. So I believe not even like guys, but also girls, ladies, could be able to just lift the bruise and work with it easily.
Yeah.
That's a great point. We were just talking to Barrels of Fun as you were standing here a moment ago, and they were saying, sometimes you have an idea and you think, that's not going to work, and then they were saying how important it is to just go try to do something.
Yeah. That's
a great point too. You want to work on a robot. Well, it's too big, it's too heavy, it's too dangerous, it's too XYZ, fill in all of the blanks. Great way around it.
Yeah,
shrink
you're
the
naturally
scale,
staying away from it.
Right. Yeah.
And the whole idea of Bruce is to invite people to play or work on it. It's not like something that will never break. It's not something that will be standing there all the time. Things break, robots fail, but with Bruce, you do not need to be afraid about breaking it. It's really easy to fix. You can 3D print almost all the parts, and the aluminum parts will never be broken. And then if it fell, it fell, and you just pick it up and start with a new thing.
So I always say, the lowest common denominator of our attendance at this conference is that many of us consider ourselves SolidWorks users. That's a very important lowest common denominator, of course, but when it comes to using SolidWorks for the design, for testing, for, of course, compatibility in human use cases, how did SolidWorks really come into play with your robots?
It comes to not only just designing, basically, of course, we draw our parts in SolidWorks, but also what's more important is simulation capability of SolidWorks. Every part, I'm not kidding, almost every part on Bruce, I would say 90% of Bruce, has gone through the process of simulation in SolidWorks. It's a whole process. If it's thermal related, it's gone through structural, thermal behavior, and then topology optimization, and probably go back and do the whole loop again. If it's not thermal related, at least it's gone through structural and topology optimization, so that we can bring down the robot to about 5 kilograms and still maintain some stiffness.
Very neat. So if we look forward into the future, I mentioned 2 to 3 years ago thinking about AI programmed robotics in an actual sense seemed very far off, right? You would have said like, oh yeah, that's a science fiction novel thing. I'm probably never going to see that in my lifetime, maybe, right? Probably not you. You had very keen aspirations for this, but I would have said that.
I'll try our best so that you can see it.
Right, but. I like to take inventory of time. We are in 2026. We're at past the halfway point of the decade. So if I think forward even further, let's say I think forward to say a year like 2030, for instance, and I think
5 years later.
What's that?
Basically 5 years later.
Yeah, basically. What does sort of the robotics field look like then, right? What do you realistically expect robots like yours to be doing alongside humans around that time frame?
I think robotics field will be continuously, playing an important role for people. As this field is basically generating productivity, and we believe that our robots will be kind of like a standard teammate in your daily operation or your daily production. Probably not so fast into our homes, but in daily production, your operations, that robots will take care of some of the, or hopefully most of the physical and repetitive or dangerous jobs for people, and then we can focus on the parts that truly require humans' intelligence.
Awesome. Well, cool. So Westwood Robotics, you heard it here. And maybe who knows in 2030, maybe Themis or Bruce or maybe their future brother will be my co-host here on Live. Maybe I'll replace Jesse.
You'll never know.
Sean's always looking to replace me with a robot. Every year he's trying to replace me with a robot.
But Dr. Zhang, thank you so much for jumping on here at the live desk. It's been a pleasure.
Thank you.
All right, so we're going to continue on with our design reviews here with Sparx Hockey in just a moment. Stay tuned.
Well, in these segments, we've gone through some designs that move people emotionally, physically. Next up, we're here with Russ Layton, Sparx Hockey. You certainly move people literally very quickly and sometimes dangerously, it seems, on the ice.
Yep.
You've got yourself here a pretty cool unit. I've talked to you about this several times. Do you want to explain what we're seeing in front of us?
So what this is we've taken professional skate sharpening and we've turned it into a consumer product. And what that did was it ushered in kind of a new generation of hockey players and families that sharpen at home. And then after we were successful with consumers, we started seeing adoption, all the way up to the NHL at the team level. And then 4,000 retail partners actually are sharpening commercially in stores with our product as well now.
Yeah, amazing. It's got to be difficult to, well, I guess let me ask you, was it your intention to initially make a product for essentially everyone in the field, or it just kind of grew into that as you went?
Totally grew. We actually didn't expect it. Initially, this was all about solving a consumer problem. I was a mechanical engineer, and I had this huge consumer need. I wanted to sharpen skates without the drive to the store, the weight, the inconsistency, the inconvenience. And rather than designing products for someone else, I decided, let's solve my own consumer problem, and it's just pretty much gone viral from there.
So tell me a little bit about that problem, because I am not a hockey player, so I probably wouldn't have known that was an issue, but it sounds like in your past that was an issue for you. So what is the process? Normally you would get your skate sharpened at the rink, or how would that work prior to you?
I think most people don't realize how often you get your skate sharpened.
Yeah.
Most professionals will sharpen probably multiple times a game, and then consumers, consumers, if given the option, would sharpen every single time they skate as well. It's only because of the inconvenience that we've accepted for generations. We only sharpen when our skates are completely gone. And so, like when I was a kid, we would sharpen once a week, once a month, and now I sharpen multiple times a week.
Is the blade on a skate a consumable item, or is it built? I don't even know how skates work.
It is a consumable. So the blade, it's a stainless steel blade, has a pretty predictable curvature to it. And the grinding, we call this the grinding ring, which is our grinding wheel. This travels along the bottom of the skate blade, removing material. And you can do about 150 skate sharpenings before you've removed enough material that the blade actually needs to be replaced.
Wow, okay, interesting. So tell me a little bit about the process, because I actually didn't even know. So a blade of a skate is concave, I think you were telling me, which is, I didn't even realize that.
And that's the old way we did this, where we went to a store to get our skate sharpened. A lot of people who skated maybe knew their blade was concave, but didn't know they could adjust that concavity to affect performance. And so the deeper your hollow, the more grip you have in the ice, and the flatter your hollow, the faster you go. And so with Sparx, we've now enabled a whole generation of hockey players, figure skaters, to be able to tune that hollow with different versions of this to trade off grip and glide and potentially get better athletic performance.
Sure. Now, is that something you would know as a skater? Like when you go to get your skates sharpened from somebody, do you say, I want a such and such radius previously, or is that something that's just, you just hand them over and get what you get?
That was how it used to be.
Yeah.
And I think over the last, so we've been at this for 12 years, 10 years commercially. And in that time, a lot of our social media has been educating the consumer with the knowledge of the hollow and that you can tune it for performance. And so I believe now most kids growing up and most adults do know that they can change their hollow to affect their performance.
Huh. Yeah, that's really interesting. It's not something I feel like that really happens a lot, where a technology comes along that also builds in more knowledge into the customer base as well, right?
Yep.
If it's there, I guess there are still some situations where something is just a black box and you turn it over and you get it back. But that is very fascinating. Now, as far as the design, you said you're an engineer yourself, so you had this problem kind of stuck in your mind for a while, and you're thinking, okay, what can I do about it? Prototyping, I think you said you just went and kind of built an erector set of it. Like, can I get this to even work? And then sort of took it from there?
Yeah, so the way the company was conceived initially was I purchased a manual skate sharpener.
Okay.
And then I wouldn't actually have known how easy the problem was to solve until I actually tried sharpening like a professional. And then I realized that it was constant pressure, constant translation speed. It was all these constants that we could engineer into the product. And so building the erector set that you talk about was really to figure out how to manage all of those constants with an engineering design.
That's really interesting. I was talking to Pablos, our keynote speaker, yesterday, and he was talking about people being T-shaped, which I don't know that I had ever heard before, but it's, you know, having a lot of people have interests that are really wide. They know a little bit about everything, or they could be a really expert in one given thing and they don't really know anything about anything else. But people who are T-shaped, they have a lot of, you know, miscellaneous interests, but they're really good at one thing. So I kind of see that in you, where you're an engineer, but then it's like, oh, all of the other interests, you can tie that information back. And people like that are the ones that make those connections, right? Because you've got the engineering know-how to, when you go to do it physically, it's like, wait a minute, I could automate this. I could do something about it. I know all these forces. So that's a cool way to just tie things back and end up with an amazing product.
I think that really hits it. I've never heard this term T-shaped.
I hadn't either.
I love it
I hadn't
now.
until yesterday.
I'm going to start using it. But I think it was, you know, I'm not really an expert in any one area, but I had enough experience in business development, in hockey, in engineering, wanting to be an entrepreneur, that when all of these forces kind of arrived at the same place cosmically, I was like, I have to go do this. Like, why don't we build this product?
There's a question there's a point there that I think you're hitting on, and even the background video shows it for sure, because you see all these different contexts, and like, when you tell your story, I understand exactly what led you as a person to do this specific thing. And so you're building for yourself, you're trying to solve a problem for yourself, but then it's abstracted, right? You start to need to build a device which looks super portable. It could, as we can see, evidently, you can even have it in your living room if you're playing, you or your kids are playing hockey.
It goes anywhere.
But what kind of challenges then arise out of that? Because it isn't just you anymore trying to use the device. It's families, kids, people like rink operators, people you might think of, even if you don't play hockey. It's like, I can see this person sharpening skates. And then people you wouldn't think of, where it's like a mom or a dad who isn't as handy.
Yeah, I was telling you, I was over at my brother-in-law's over Christmas, and my nephew sharpened his skates for me on your Sparx unit. I was like, wow, this is pretty cool.
Yep. And that was really core to everything we were trying to do.
Yeah.
We had the model of like a single serve coffee machine, and we were thinking it has to be just one button easy. It has to take this very esoteric action of sharpening a skate and make it as easy as making a cup of coffee with one button.
Yeah.
So we've really jumped all of that confusion and turned it into a simple consumer product that now even commercial users are purchasing, because they want the ease of training, retaining staff. And so the commercial side of our business, which we never expected, is actually a sizable, very important part, that B2B, us selling into retailers that are sharpening.
Yeah, my brother-in-law was saying he bought some for their rink as well, and they just use your system as well. So talk to me about scaling the company a little bit, because it sounds like it wasn't really your intention to kind of blow up in the way that you did. I'm sure some of the people online are entrepreneurs or budding entrepreneurs. What was that process like for you, going from, okay, I have an idea, let's make it out of a erector set, to this, where you're now working with the NHL?
I think one thing in the early part of, I had this consumer problem, and then I actually started asking the people that I played hockey with, I'm like, is this bother you? And it was like universal. Like, everyone knew this problem. And I was like, I'm onto something. And then there was the froth. This is 2012, 2013. There was this froth of everyone on Kickstarter. So it was the coolest cool, or it was the Pebble Watch. It was all these things. And I was like, wow, I have this idea. Everybody is saying it's a problem. Let me take this concept I have and go on Kickstarter. And then the problem was we sold a lot of them on Kickstarter.
New problem.
And then we're like, well, we have to figure out where we're going to build this. So then it was taking this, concept, some early CAD, and going around to contract manufacturers, and that began the real challenge of bringing this product that was solving a problem to market. And then there's the whole entrepreneurial journey of, I was 37. I think a lot of entrepreneurs out there that are 25 just go. I waited too long. I had 2 kids, a mortgage. And the aha moment for me there was actually hiring some young engineers to start making progress. So the entrepreneurial journey, the logjam was, how do I quit my day job to go chase this dream? I've got a proven market, a product, sales. Like, how do I go do this full time? And it was having somebody start making progress. And then it was unstoppable at that point. We just started. I was like at the at the cards table, and I was in. I was going to either lose it all or go big.
Right, right. Yeah, and I was going to say that's probably the point where people get stuck. But I guess you're fortunate in that you were already in the circles of your market, right? So you had pretty good confidence that, okay, this is an issue. There is a market there. As long as we can make the product work, we're going to be able to sell it. And obviously, Kickstarter is a great confirmation of that. If you sell out quick, it's like, okay, well, this can work, right? So I guess gaining the confidence that and your idea has a market, and whatever price you can set to it is appropriate for the market value. That's probably the key, right? Then you can go all in on it.
Absolutely.
So once you get to that point, though, so you have customers, you have people using it. It's then, all right, so you have millions of sharpenings, right?
Yeah, we do over 10 million sharpenings a year now in 35 countries.
So as we wrap, like, how do you incorporate that feedback into the product? We monitor a lot of Facebook groups. There are organically created Facebook groups, and so we're constantly watching what the customers are talking about, which is such a modern ability to watch the customers give you feedback. Our products are now connected, so all of our data is coming off of these machines and going into the cloud, and so we can watch feedback from the customers. We can see errors and problems with the products and incorporate that into the engineering. That's awesome. Well, Russ, thank you so much for stopping by. I'm hearing in my little earpiece that we're about to start general session. It's Sparx Hockey, Sparx with an X, right?
SparxHockeyWithAnX.com.
We thank you for coming on the show. My niece and nephews, thank you for sharpening their skates.
Yep. All right. Stay tuned. General session is about to start.
Please welcome back Tracey Wilson.
Good morning. Good morning. Woo, welcome to day 2. I hope you all had a fantastic day yesterday, reconnecting and making some new friends. Yeah, I heard a shout out earlier. Yeah. I'm never going to turn down a woohoo. You know, and since it's day 2, I thought today we could give a special round of applause to those who came back for the second time. Welcome back, two-timers. Welcome back. Yes, because once you come, you are hooked. Well, we have another great morning for you. Today, we will go beyond expectations. We'll share what's coming in industrial AI. We'll share what's coming in the new releases of Solidworks. And we'll hear from customers who are leveraging AI in their own product development process. So without further delay, to get us started, it is my pleasure to welcome to the stage Dassault Systèmes CEO, Pascal Daloz.
Hey! Thank you so much for the warm welcome, and welcome back. Today is a special day, but a few minutes before, right? Just to do a quick summary of what I discussed with you yesterday. If you remember, we talk about the future, but more importantly, we talk about how we are building it. And the future is not only about empowerment, it's also about inventing new things, opening new possibilities with you and for you. So if we step out for a moment, you know, the previous century, the 20th century, was really about the industry using and producing objects. In this new century, industry is producing knowledge and know-how, and the knowledge and know-how are generating the objects. This is where the true value lies. This is where the power is. And that's why we bring together the virtual twins and the 3D universes. 3D universes are not applications. They are knowledge factories. Factories where the knowledge is enriched, the know-how is scaled, and the results are trusted. And to supercharge this, we are using AI. Not a generative AI, not a surface-level AI, but what we call a real-world AI, grounded in industry, engineering, and science. So it's not only about large language model, it's about what we call the world models, because LLMs do not build satellites. They don't design aircraft. They don't discover cancer therapies. You do. And we help you to certify it. So the world model makes, in fact, the virtual twin truly generative. And to make this possible, we combine the power of the virtual twin with the accelerated computing. And to continue these conversations, I'm now very pleased and honored to invite on stage someone who is defining, someone who is shaping the foundation of artificial intelligence. So please give a warm welcome to Jensen Huang, founder and CEO of NVIDIA.
Pascal. Hey, everybody. Are you called solid workers?
Hard workers.
Hard workers.
So welcome on stage, Jensen.
Thank you.
It's always a pleasure to have you. I don't know if people realize, but we have a long-standing relationship, right? I think we almost started the collaboration 30 years ago.
Yeah, over a quarter century ago.
You remember how it started?
Well, we started during the last computing platform revolution. In fact, the personal computer revolution. And what used to be Unix workstations was migrating to Windows-based workstations. And the technology that made it possible for us to collaborate was based on OpenGL. And we invented a technology called CGFX, which is the precursor of CUDA. Yeah. OpenGL became RTX today, fully path traced and physically based. And CGFX, of course, became CUDA. And here we are working together again as we reinvent the computing platform. You know, everything that we do is in the digital world. 40 years ago, Dassault revolutionized the idea of virtual twins. The idea of a virtual twin, of course, is to represent the physical world in a computer. And so now we're going to represent the physical world at a much, much larger scale in a completely revolutionized computer, an AI computer. And so this is a really, really fantastic time.
You're right, it's an incredible journey. And as you said, now we are entering into a new chapter. We are now what we call in the generative economy, where we are powering the virtual twin with accelerated artificial intelligence. From your perspective, Jensen, what is happening in the global industry right now?
Well, we're reinventing the computing stack altogether. And as you know, in the last generation, the representation of the designs were structured representations, meaning we specified every geometry, we specified every material, we specified literally everything. Now it's going to be a generative computing model. And in the world of generative computing models, the entire computing stack is being reinvented. And because AI is foundational to every single industry, it is going to become an infrastructure. Just as water was infrastructure, electricity is infrastructure, internet was infrastructure, now artificial intelligence will be infrastructure. We're growing so fast because every single industry needs to build it, every single country will be powered by it, and literally every society will have it. And so this is the beginning of a new industrialization, which is really fantastic for you because, as you know, Dassault is the engine of the representation of everything that you want to build. And in the future, in fact, you know, in the past, I would say that we spent a third of our time in design, in digital, maybe 2/3 of the time in physical. It is very likely in the future, we're going to spend 100% of the time in digital. And even after we're done designing it, simulating it, validating it, we have to integrate it with software. And so everything that's inside the Dassault systems, whether it's CATIA or Simolia or BioVia or let's see, what are the other Vias? We got Delmia, we got Innovia. And listen, all of those Vias are going to be built on top of NVIDIA. Did we know that a quarter century ago? And so anyhow, the design, the representation, all the simulation, and even the operations of it, because everything will be software defined in the future. You know, everything from a pair of tennis shoes will be software defined in the future. And so cars are software defined. The robots that build the cars are software defined. The factories where the robots, you know, are orchestrated, build the cars are software defined. And the cars themselves are software defined. So everything will be software defined. Everything will be represented inside Dassault. And so we'll be designing everything, operating everything really as a virtual twin and realizing your vision for the first time.
Yeah. You know, before we go further, if you look around the crowds, you know, at Dassault Systèmes,
kind of a ruckus crowd.
Yeah. At Dassault Systèmes, we work with 45 million people around the world, 400,000 customers, more than 15 million engineers, researchers. So I think you have here probably one of the, if not the largest engineering community in the world. They do more than half of the products surrounding us every day, robots, you know, drones, planes, cars, medical devices, drugs, home, city, factories. So this is an amazing community, don't you think so?
I know they think so. Absolutely, yeah, we're all engineers.
You are an engineer.
Yeah, sure, I'm still an engineer.
So you belong to this community.
I am. If I was to start all over again, I chose to use Solidworks.
You know, that's why the world model matters, in fact, because for this community, the success is not about automation. They don't want to automate the past. Mm-hmm. They want to invent the future. And this is the reason why we are announcing this new chapter in our partnership, because together we are bringing the virtual twin factory with the AI factory. This opportunity is really enormous for you guys and for us. So to prove the power of this, right, we have some concrete example. I think Jensen and I, we have selected some use cases we want to share with you. Let's start with research and engineering first.
Yeah. And so, you know, remember that almost everything that we do together starts with the computing platform. And when PCs went into the cloud, Dassault reinvented yourself again. When now we're extending from cloud to AI, we're reinventing again. And so today, we're announcing a massive partnership. This is the largest collaboration our two companies have ever had in over a quarter century.
Yep.
Dassault is going to integrate NVIDIA CUDA-X acceleration libraries, NVIDIA AI for physical AI and for agentic AI, and NVIDIA Omniverse, our version of digital twin technologies. And so all of these libraries represent our body of work over the quarter of a century. Now we're going to fuse these technologies into Dassault so that all of you will have the benefit of accelerated computing, artificial intelligence, and be able to work at a scale that's 100 times, 1,000 times, and very soon 1,000,000 times greater than what you were able to do before. What used to be, pre-rendered, or what used to be offline simulations will now be literally the virtual twin vision that you've always had along. Everything will be done literally in real time. We'll design products and simulate it in a wind tunnel in real time. We'll connect these robots and let them operate in a factory in real time. Yep. And they'll be building your products literally in real time. And all of this is going to be happening in the next 5-10 years. This is going to be extraordinary.
Speaking about this, let's start with life. I think life is the most complex system ever created, right? When you think about it, how much knowledge is encoded in the living world. With our virtual twins, we are learning from life. We are also understanding it in order to replicate and to scale it. So this is possible.
This is NVIDIA AI integrating with BioVia.
Yes.
BioVia, right?
And we will come back to this.
Yeah.
But this is possible because I think we have this foundation, we call it the world model.
Yeah.
The world model where it's grounded in biology, in physics, material sciences. So the key question I have for you is, what does it take to compute a world model for life, or of life?
Well, the most important thing, the first thing that we have to do is understand the language of life.
Yeah.
And so, of course, in the world of physical design, the design started with your imagination, and you represented that physical object using structured information, geometries and textures, that were designed by you. However, life is different. Life existed before us, and so we have to go learn the language of DNA, learn the language of proteins, and learn the language of cells, and understand how they interact and its properties. That first stage of learning the meaning of life is what we are in the process of tackling. The second part, of course, is generative. Once you could learn something, learn the meaning of something, we can translate it between languages. We can translate between human language and the language of biology, between the language of biology, and interpret it so that we can understand it in human language. Beyond that, you can now translate and generate new proteins that could be used for a drug, or generate new chemicals that could be used for a drug. And then, of course, generate new materials that could be stronger, be more heat resistant, lighter, easier to manufacture, last longer. All of those properties are now kind of within our grasp. And this is one of the reasons why this is likely going to be one of the most impactful areas of engineering in the next decade.
Exactly, and it is already happening. In fact, we have a case, the Bell Group, them, they do the famous Baby Bell. And their mission is very simple. They want to basically produce healthier foods for millions of consumers, but at the same time, they want to consume less water, and they want to progressively change, or at least complement, the dairy protein with the non-dairy proteins. So that's the reason why they are inventing what we call the food science. Before, hundreds of physical tests for one single product. Now, they generate automatically, and this is what you can see on the screen, they generate automatically the protein from the virtual twins, because it's, again, powered by the biological world model. So the result, it's not only faster innovations, it's also certified decisions, because you cannot play when you have the life of the people in your hands. That's what we do. Now let's move to something else. And you started to speak about it. You have seen on screen, this is changing, in fact, the daily life of the engineers. In the SPA, now you define the specs, you run your simulations, and automatically, the generative experience is producing and exploring, in fact, the space of possibilities and finding the optimum solutions for you. Actually, the virtual twin is exploring an infinite of possibilities. So the question I have for you, could we compute infinity?
We can't compute infinity, but we can imagine infinity, which is the reason why these surrogate and emulation models, the fusion of simulation and artificial intelligence is so powerful. 8 years ago, I introduced the idea to scientific computing and simulations, the idea that in the future, not only will we use principled simulations, where the equations, the laws of physics are well understood and well represented. However, the simulation time takes way too long. Why don't we augment that with generative methods of predicting the future using artificial intelligence? It's a little bit like, the analogy I would give, it's a little bit like our dogs able to catch a ball out of the air, and yet they're not doing physics simulations of balls bouncing or elastic nature of the ball. They're just literally watching us and predicting where it's going to go, and they snatch it out of the air. And so the idea that an AI could learn how to predict physics and learn how to predict very accurately how materials would crumble, what happens to a crash, those things, those capabilities are within grasp. We have a technology called Physics Nemo. Physics Nemo is essentially a physics-aware AI model simulation system and AI framework that allows us to create these AI models that are either trained by principled simulators or work alongside principled simulators, so it's grounded in the laws of physics, but able to predict 10,000 times faster. And now, if everything is already running in real time, then you can predict at 10,000 times greater scale. And that's just where we are right now. Imagine where we're going to be in the future. The idea of simulation and emulation coming together to help you design is going to be really revolutionary.
And again, this is exactly what you see here with a customer called Lucid. You know, we know them. They are one of the most innovative car company in the world. And what do? In fact, they embed the crash behavior, the aerodynamics, the vehicle performance upstream early in the vehicle program's development. So the engineers, they don't only design the shape, they design the behavior, and we certify it. So this is exactly what you say. This is this joint vision, empowering designers and engineers, and also unlocking the business people, you know, to develop the delightful experience for their customers. Now, let's talk about factories. You start to touch a little bit this topic. The factories are not anymore today only a physical asset. I think we are all in agreement with this. It's made of virtual and real at the same times. So let us know how physical AI is really used to run the factories.
Well, the way that people used to think about designing products is they design the product and they build the factory. In the future, it's very likely that the products that you are able to design and build will a lot be impacted by the factories you design and built. And so it's very likely in the future, well, it will be, it's in fact now, that every single factory is designed in CAD, that's obvious, but it will be simulated and operated completely inside a virtual twin. And operating a factory of these gigantic scales inside a virtual twin is extraordinarily complex. A factory is not just one object, it's millions of objects. And we want to also simulate or emulate how these factories will operate in the real world so that we could arrange the manufacturing lines properly, arrange it in the right sequence, space it properly, organize the robots within it, run the robot AIs so that these AI robots could be operating inside the factory, manipulating things, assembling things, moving things, keeping things safe. All of this is going to happen inside a virtual twin. And so, you know, Dassault's, the products that Dassault is going to help people build and design are going to become gigantic in the future. These are going to be systems of objects, systems of AI, systems of robots, all coming together into a giant factory.
This is exactly...
You're going to need some fast computers, is what I'm saying.
And again, this is exactly what we do with Omron. you know, you have seen on the screen, they don't use the virtual twin only to visualize the factory. In fact, they do much more. They engineer what we call a software-defined factory.
That's right.
And where the difference is coming from is, in fact, they are designing the autonomous part day one. It's not something they come when the production system is already up and running and they try to infuse the autonomous part in it. So as a result, those factories, they become much more flexible, resilient, you know, and also adaptive. But there is another kind of factories, right? And you talk a lot about this. The AI factories. They are building everywhere. They are extremely complex. What does it take to make them, or to build them and to make them a reality?
Well, we're going through what clearly is a new industrial revolution, a fundamental technology that impacts the productivity of many industries. That's why it's an industrial revolution. Just as energy did that, just as mechanical energy, power did that, just as electricity and, of course, the internet did all that. We're now seeing artificial intelligence doing that. In order to make this possible, we need to industrialize and really scale 3 different giant industries. The first one, of course, is building a lot of chips, which is the reason why the number of chip factories are increasing. You're involved in a whole bunch of chip factories, and so chip factories and packaging factories, just to make all these semiconductor products. The second is computer factories. Once the chips are done, it goes into another factory. What comes out of that is a supercomputer. Those supercomputers go into an artificial intelligence factories. Right now, as we're speaking, these 3 entirely, what used to be 3 different industries, are all growing incredibly fast so that we could create the infrastructure for intelligence and manufacturing the AIs. While these factories are incredibly complex, they're, you know, a gigawatt AI factory is about $50 billion. And now we're building tens of gigawatts around the world. It's an enormous infrastructure build out, the largest industrial infrastructure build out in human history. And so the amount of technology that comes together inside these factories are extraordinary. And we want to make sure that they work the first time. And so the way we're doing it, we're using MBSC, a Dassault product, mechanical, what?
Model-based design.
Model-based design. So,
engineering.
I wish you would have been something via. You know?
Not yet, not yet.
Okay, all right. So, you know, MBVIA, that's it. Model-based VIA. And then so what goes into them, what goes into these systems are giant data centers with lots of supercomputers. The amount of energy necessary, of course, a gigawatt, largest factories ever, and it costs so much money. So we design, we plan, we simulate everything in MBSC before we build it. And so our expectation is, and we even run the network and run the supercomputers inside the virtual twin before we even break ground. That allows us to save tons of time and tons of money. And over time, of course, this data center has an AI that keeps it optimal. Yeah. It's AIs that modulate the performance, modulate the power, modulate the temperature, modulate cooling. And in doing so, if you want to do so successfully, you need artificial intelligence. And so that operating loop, so we're going to have these virtual twins of these AI factories running forever, training and updating our models.
So again, this is proving that the virtual twin is not only about 3D. Yeah. It's, as you say, it's about revealing the architecture, revealing the system underneath, and obviously revealing the knowledge at scale.
And it looks real.
And it's real.
Yeah, right? It looks real, right? It looks real. It operates really. It integrates all, you know, industrial bill of material. And so the bill of material comes in from manufacturers and suppliers. We integrate everything really physically. And so we have a very clear list of bill of material. We know exactly what we're going to buy. We know which part is going to integrate with another. We could see in advance where there's something fits or doesn't fit. We know exactly how many parts. So the inventory bill of material of the supercomputer comes out, this AI factory comes out, adds up to about $50 billion bill of material. And so this is incredible. And we have everything digitally. And so, you know, no mistakes will be made.
Now I'm counting on you to sell it to your ecosystem, right?
Yeah, absolutely. Well, we're the first customer.
You are?
Yeah, we're the first customer.
You are the first customer. Now, the next topic I want to discuss with you is really how do we put the knowledge at work? So this is exactly what our virtual companion they do. We made a live demo yesterday just to showcase what is coming. And you know, engineers, they spend too much time to look for informations or to do something else. This is not engineering. So now look at it. In few seconds, you know, you started from a sketch. We produce automatically, we moved from 2D to 3D. It's a full parametric model, simulation ready. I think this is really revolutioning everything people are doing, and it's changing completely the workflows. Now, there is a question in this room. And the question is this one. Do you think this will replace the engineers?
Well, before I answer that, one of the really revolutionary things that has made possible for us because of AI is the ability to go from and interchange between structured information and unstructured information. Unstructured information is essentially a photograph, or it could be a recording, it could be a video. And we want to take that unstructured information and now represent it in a structured way. We need artificial intelligence to go from 2D to 3D, image to 3D. And once you have it in 3D, that information is precise, it's controllable, it's interchangeable, right? We can enhance it, we could improve it, and so it's now in our structured database. We can go from structured to unstructured, obviously, very easily. And so now we have the representation, the ability to use agents and use AI to manage our information so that we can augment the design process. We could decide that this part I'm going to design specifically by hand. Here I'm going to take an image, I'm going to import it, and then I'm going to modify it, so on and so forth. Now, these agents are going to be companions of ours because we're going to essentially be their manager, their architect. We're going to be the manager, the architect, the creator, and we're going to have a lot of agents or companions help us perform different tasks. Whereas most people think that the number of designers, therefore, will be less than the past. And the number of software tools that you will use will be less than the past is exactly the opposite. It is very likely, and I'm certain this is going to happen, that every designer, every SolidWorks designer, every designer in the future will have a team of companions. And you've trained these companions, and you've taught them different skills, and you've helped them coordinate and work with each other and work with you. And they're all going to be using Dassault tools. So the number of users of Dassault tools is going to go from biological to biological as well as AI-based. And so the number of tool use will explode. And so this is the software industry, of course, is going to be great for the software industry. It's going to be great for all the designers because you have so many companions to help you do things. And what would be really fantastic is that you're working with your companions, and then it's time for cocktail, and because it's solidly 4:30 somewhere, and so you kick off your team to go explore all these different areas. And I want you to explore this, I want you to explore that, I want you to optimize for these areas and give me 3 designs. I want to optimize for these areas, give me 10 designs. And when you come back, you have all those choices, and then you can go in and fine-tune it specifically yourself because you have the structured data, the 3D data. And so I think that the opportunities to reinvent how you think about design and creativity is going to be completely revolutionary for everybody.
That's also something we can showcase. In fact, you take NIAR. NIAR is the National Institute for the aviation industry. They are based in Wichita, and they focus on research, testing, but also certifying. And we know that certifying an airplane, it's a nightmare. It takes between 3 to 5 years. It's more than 10,000 requirements you need to be fulfilled. Now, I think with the virtual companions, what could we do? The regulations could be automatically ingested, right, without having to read millions of pages. And the conformity is constantly verified, which means now we are moving from, if you want, it's by design. It's a compliance by design, right? And there is and it's not anymore a cost. It could become a competitive edge, in fact. So the question I have for you is, how does it take to move from a language model to a world model?
Well, the language model has to obviously understand syntax and vocabulary and structure of language and has taste. You know, what's a better way to compose a paragraph? And it has guardrails. What are the things it should talk about and things that it should avoid talking about? In a world model, instead of taste and values, it has to obey the laws of physics. It has to understand causality, that if you tip over a domino, you know, all of the dominoes that are connected to it or nearby it will be tipped over. It has to understand what comes after and what comes before, and understand inertia and friction, understands gravity, of course. It understands contact. You know, all of the things that you understand as you're designing things, we have to teach the AI that sensibility. That's not necessarily captured in language, and all the language in the world won't capture that. And so we have to use laws of physics and simulation and a whole bunch of examples to teach it the laws of physics. And then, of course, one of the things that you mentioned, design for manufacturability today is integrated into the design process. Instead of you coming up with a design and then another team decides whether it's manufacturable, design for manufacturability is really upstreamed, shift it left. We want to shift left basically everything. And so one of the things that are very hard, as you mentioned, compliance is hard, because that's where machines meet society and humans. And so that language model where human values could be now integrated into or shift left into the design process. And so you're constantly in compliance. You're constantly obeying the laws of physics because of the world model. You're constantly designed for manufacturability. You're constantly designing to use components that are approved with, you know, vendor approval list and whatever it is, so that by the time that you're done with the design, it's good to go. Yeah.
Now, I hope you have a better idea about what this partnership is about. I think together with NVIDIA, we are delivering the knowledge factory. And to power the virtual twins with our virtual companions, with an accelerated AI computing. This is more than performance. I think it's, as you say, it's an acceleration. But more importantly, this is opening the new possibilities. Whatever the size of the company, whatever the industry you are in, I think we help you to certify your decision. We help you to eliminate the bad choices before they become expensive mistakes. And we also help you to create new categories of solution. You call it the software-defined products, the software-defined factories, the software-defined objects at large. And more importantly, we need to protect your knowledge as well, right? So how do you think we can protect the knowledge of all the millions of people using our software?
Well, first of all, before I go there, I think that our partnership today and what we're announcing is really genuinely extraordinary. The type of things that you will be building in the future are simply impossible without accelerated computing. It's impossible without real-time simulation. It's impossible without artificial intelligence. Instead of thinking about what could be more productive, yes, productivity is going to be enhanced, and you'll be a lot more productive, and you'll be able to do things more quickly than the past, just as PCs did that for us, just as the cloud did that for us, just as the internet has done that for us. Every technology revolution had made us more productive. However, this time, the type of things that you'll be able to do, when you think about the scale, 100 times, 1,000 times, 1,000,000 times, these are going to be things that are just simply impossible to do before. Now, our partnership started with computer graphics. And our computer graphics, as you've seen, become fully ray traced and physically based, and it looks completely photorealistic, and it's real time. And so the foundation of our partnership has always been RTX and computer graphics. But we've now extended it to CUDA-X, we've extended it to AI, and we've extended it to Omniverse. All of these computing platforms sitting on top of accelerated computing and NVIDIA's GPUs are going to revolutionize the tools and revolutionize, therefore, how you design and what you can design, and ultimately how your companies operate. And so I think that that's number one. The other part that's extraordinary, of course, is that in the future, almost everything that we do will have AI in the loop. You know, when people think about AI, they have humans in the loop. And that's important. But remember, you also now have your companion, your AI in the loop. That AI is going to remember how you'd like to do your preferences. And that AI, therefore, will codify your skills, codify your preferences, codify your habits, codify the domain expertise that you have. And that is your companion. And that companion sits with you. It's not going to be in the cloud, not going to be public, because it captures your expertise. You know, if you look at my inbox, in a lot of ways that's captured 33 years of my knowledge, of my expertise. It's not available for everybody. It's not open sourced, of course. And it captures a lot of my sensibility and a lot of my knowledge. In the future, I will have companions that are going to continue to work with me. I wish I had it 33 years ago, to be honest. And now all of you will have companions that codifies your knowledge, codifies your sensibility.
Last word about why do you think this partnership is unique? You already say a few words, but you are also partnering with other companies, especially in our space. Why do you think what we are doing together is something unique?
Well, Dassault, your place in the world of virtual twins, your vision that started it all. CATIA will always be CATIA. Solidworks will always be Solidworks. Simulia will always be Simulia. You know, all the other EAs will always be, you know, and you'll come up with other EAs. And they'll all be built on top of NVIDIA. That's the part that I like the best. But, but the ecosystem that you serve, the ecosystem, and all of you here that are so passionate about the Dassault products, and all of your companies that are built on top of Dassault products are now going to be accelerated and amplified by accelerated computing and AI. And that's really what's really exciting here. And it happened at precisely the time when the world is reindustrializing, starting the largest industrial infrastructure build-out in human history, trillions of dollars, tens of trillions of dollars. You know, estimates have it close to 100 trillion, $85 trillion in the next 10 years. All of that needs to be designed, simulated, validated, right? Prototyped, and of course, because everything is going to be software defined and everything will be AI driven, all of that needs to have virtual twins. And so I think the vision that Dassault had 40 years ago is coming true.
It's coming true.
Yeah, and it's coming true right now, and this partnership brings it to life. And so I'm delighted to be partnering with you, Pascal, and you know, our quarter of a century partnership means a lot to me. You know, it really, CATIA brought NVIDIA into the industrial workstation world. And today, we still, CATIA and SolidWorks are, you know, to us, very, very personal and really important to all of us. And without all of you and the amazing work that you do, many of the things that our you know, engineering and scientists pursue wouldn't have an opportunity to come to life. And so I want to thank all of you for all the incredible things that you do, and Pascal for the great partnership, and all of my friends at Dassault. Thank you for everything.
Woo!
Thank you.
Thank you, Jensen. Now, you belong to this community.
Oh, well, yeah.
Right? So make sure.
I am definitely a solid worker.
Make sure you come back. And if you are not coming back, send your virtual twin.
No, I'm coming back. My virtual twin gets to stay home and work.
Okay.
Right, take care, guys.
Take care, guys.
A unique partnership combining Dassault Systèmes' virtual twin factory and NVIDIA's AI factory for all industries. Where scientific and industrial knowledge and know-how meet global-scale computing technologies to form a shared industrial architecture. Model, simulate, reveal, validate. With the precision, trust, speed, and context to turn scientific results into industrial decisions. Molecular and protein simulations, accelerated 200 times. Expanded engineering possibilities with real-time simulation for every designer. Agile and rapid adaptation of industrial processes through seamless integration and training of autonomous robots in the virtual twin of production systems. Test manufacturing scenarios and validate them instantly. Deploy them within days in the real world. A new infrastructure emerges. The AI Factory. A system that produces intelligence, understood, controlled, and optimized through its own virtual twin. Driving a new workplace revolution through an agentic platform of skilled virtual companions to enable strategic human-machine collaboration at every stage of work. Together, we are making world models for industry a reality, where virtual twins and accelerated computing work as one. Trusted decisions grounded in science at scale. This is the future of industrial AI.
Thank you so much to Jensen and Pascal. The joint solutions from Dassault Systèmes and NVIDIA will empower millions of engineers to design, simulate, and operate complex systems faster, more reliably, and at an unprecedented scale. And thank you to those who joined us for the announcement. Well, we turn now to the immediate future and learn about the virtual companions coming in the next releases of SolidWorks. So please welcome back CEO of SolidWorks, Manish Kumar.
Good morning again. That was incredible, wasn't it? Two visionaries sharing one stage, talking about where the technology is headed. Moments like these remind you that you are not just watching the future unfold, you are in it. But the real question is, what does that mean to you? And today I'm going to take you through a deep dive. Now, for SolidWorks, AI didn't appear overnight, right? We have been delivering it over years, delivering AI capabilities that are already helping you work faster, more efficiently today. But what's different now is the scale. We are moving beyond isolated features now. We are embedding intelligence directly into the design process, starting from the very first idea. These are our virtual companions. You saw it yesterday. They are your expert partners there when you need them, helping you deliver better work faster. Every great design starts with curiosity. That's why we start with Aura. She explores, she connects. Aura embraces existing knowledge and know-how to inspire you, to guide you when you start something new. You can ask her for help directly from inside SolidWorks. You have one robot, you're trying to go towards BattleBot. What can you do? You can explore options, search for inspirations, and test new directions without exposing your idea to the rest of the world. Your search stays yours, your creativity stays yours. Now, once the idea takes shape, the next challenge is turning it into something real. That's where Leo steps in. Leo is your expert guide that is going to help you. Now, in this particular case, let's ask Leo to generate that assembly structure for the BattleBot, to plan out our design. He gives you a starting point so that you don't have to start from zero. It knows what components needs to go in there. But you don't just have to take it. You can iterate it with Leo You can finalize it, and the moment you finalize it, you have the assembly structure. In future, we will also be able to grab the assembly components that you may have from your repository or even from your suppliers to give you the assembly. But today, you are able to get the assembly structure. Now, not every design starts from a blank screen. Very often, you're starting from what already exists. And this story was inspired from a real scenario. One of our teammates, Priyanka, a mom, her toddler Kabir, and mom's need of carrying a cup. By the way, both mom and son are here. You might see them walking out there. With image to mesh, you can take an image and quickly convert it into 3D mesh to provide the context in which you are going to build real things. In many cases, design from suppliers are neutral BREP geometry, for example, step files. They are accurate, but difficult to edit. Leo helps you to convert this into accurate parametric features with which you can convert those supplier models into full feature-based models. Then you can modify them. You can iterate on them. And you can adapt them to your needs without rebuilding part from scratch. And once you begin iterating, that's often where the problem shows up, and all of you might be noticing it. Features fail, references break, errors appear, right? This is also where Leo steps in. It analyzes the issue, it guides you through the model, and explains you what is going wrong and how to fix it. I hope you guys like it. But in future, we don't want to stop here. We also want to fix those errors for you, because we want you to stay focused on the design, not on the detours. Now, one of the most common challenges we hear about is the assembly performance, right? As assemblies grow, even well-designed models start to slow down. Performance ultimately comes down to good design practices, and Leo is there to help. With Leo, you can now evaluate your assembly as a whole. He analyzes how it was built, identifies what is impacting performance, and explains why it is happening. More importantly, Leo gives you a clear set of recommendations so you know exactly what to change to make your assemblies run faster. Suppress fasteners in large assemblies or use amplified representations. These are the ways it is telling you how you can do things faster in this particular assembly. Now, beyond fixing issues, we also want to help you understand your design at a higher level. What if you can simply talk to your model? Ask straightforward questions. How many parts are there? Which ones are made up of aluminum? Can I provide a simple text prompt in order to convert all the parts of a given material to something else? Imagine doing it yourself manually, one part at a time. You can do it by just chatting with the model now. It's faster than doing manually. And more importantly, it lets you focus on the big picture, not on the tedious steps, manual steps. Now, that understanding shouldn't stop at the model, right? It should carry through to how you communicate it. Last year, we introduced generative drawings, and you told us that you want control. Now you can interact with Leo to define the exact specifications before the drawing is generated. It is no longer a one-size-fits-all. You want one standard, you choose one standard. If you want to choose other standard, you want to choose a different sheet size, you can specify all of that up front. Ultimately, you get drawings that reflect your standards, your intent, and your requirements. Of course, design is a very small part of delivering an overall product. You still have to manufacture it, ship it. You need to understand its costs. That's where we are bringing Aura to Delmia Works, our ERP and MES systems. Instead of navigating endless screens and complex forms, you can simply ask questions directly from within Solidworks. What's the order status? When does it ship? What does it cost? You get answers instantly. removing friction between your shop floor and your business. Now, Aura boosts Innovia Project Planner. It gives you instant clarity, summarizing your project status. You can chat with it. Where is my project? What are delivered? What are not delivered? And quick and easy access to what is blocking the release, ultimately even getting the insights. When change is inevitable, Aura helps you to understand the impact before it becomes a problem. Aura can create change action for you. It can identify what's affected, who needs to be involved, what needs to happen next. And that change is then routed to the right approver with full context and clarity. The approver receives a clear summary. Again, the approver can just ask what was changed, and he or she receives a clear summary through the virtual companions. They can review the impact and approve, again, verbally, without digging through dashboards and spreadsheets and templates. The result is faster decisions, fewer surprises, and teams that stay aligned as development keeps on moving forward. The same clarity matters even more in highly regulated and highly technical industries. Let's look at a very concrete example. If you need to run a drop test on a wearable medical device, that traditionally required deep simulation expertise. Not anymore. On screen, you will see how AI helps guide the setup of the simulation, defining conditions, loads, constraints, etc., while keeping the physics and integrity intact. You don't have to be an expert. Make a design change, rerun the simulation, all by chatting with Leo. The goal is simple: lower the barrier to advanced simulation without lowering the standards. But performance alone is not enough, especially in medical device sector. Regulatory compliance is often the most complex and time-consuming part of the process. That's where we are now powering requirements and quality management with Leo. Imagine pointing Aura to a new or updated regulation. It can help interpret the text and generate updated requirements. From there, Leo can suggest traceability links, connecting those requirements to system requirements or even to specific components in the design. The result is very simple. It is a clear impact analysis. It gives you stronger traceability and far less manual effort. This is the beauty of Leo. It does all the work for you. I invite you to visit SolidWorks AI Lab in the playground. Please share your ideas with us. What you have seen is what you can play with today. It is not tomorrow, today. But that's not all we are working on, of course, right? Let's talk about 6-month-long future, or maybe a year-long future. How about creating geometry directly from natural language? Let me show you what I mean. I showed the live demo of the ModelMania model. It was a simple scenario, right? So let's take a look at the ModelMania 2025. In fact, one friend of mine told me that it was very simple. Okay, let's take this example. What if you can just talk and ask Leo to build it for you? Build a model of a certain size. Select all the vertical edges. Add holes on the top face. Add hole on the side face. You are speaking to the model. You're speaking to Leo, and Leo is creating the model for you. In fact, this entire sequence was enacted without going to a single command. Text to CAD, speech to CAD. What do you think about that? Now, the next one is truly amazing one. I kept the best for the last, of course, right? Imagine you are someone who has to design a steel structure frame to support a water tank. By the way, before going there, I will tell you that I implemented Wellmans, and you will see it in the next segment why I am saying that. So for me, it is a heartbreaking thing, but still I'll share it with you. Imagine someone designing that I want a steel structure to support a water tank with a specification like it has to be cylindrical water tank, maximum capacity of 5,000 liters, 500,000 liters, minimum diameter, maximum, whatever. These are the specifications. What if you gave this specification to Leo, and Leo worked on it in SolidWorks, or with SolidWorks, I should say, to give you something like this in under 5 minutes, which you then can run simulation on to verify that the loading conditions will ensure that it is going to survive that weight, and ultimately deliver this design. 5 minutes. How many of you think you'll be able to do it in 5 minutes? What do you think about that? This is just the beginning. You can imagine we are going from requirements to delivering full functional model. And everything that I have shown is working today. Some of them will be released soon, FD01, I should say in a month or two. These ones may be released in 6 months from now, but everything that I have shown today to you is working. I'm not showing you any videos per se. Now, while we are all excited about AI, what AI makes possible, it's not the only way we move forward. We are also delivering more than 200 different projects driven by your feedback. From the top 10 list alone, we have delivered more than 30 enhancements. Things like quick render, annotation alignment with magnetic lines, ability to isolate components again while already in isolate mode. Small changes, real impact that you asked for. You will see these and many more such improvements throughout today and across the rest of the conference, so I'm not going to focus on them. I wish I could show you everything that we are doing, everything that we are planning for. 10 minutes is not enough, but I hope what you have seen today gives you enough and a clear idea of where we are going with this, what's possible. Ultimately, everything that we are building comes back to one thing: enabling you to make impossible possible. Thank you, and see you on the ground, on the dance floor tonight.
All right, thank you, Manish. These new virtual companion tools will help you with ideation, new designs, modification, and simulation. But as we go through the next few days, remember what Manish said. AI is just a tool in your toolbox. You are the creativity. You are the perseverance that is going to drive the future. And so now let's welcome customers who are using AI today to practice, grow, and scale their businesses. To lead the discussion, please welcome Vice President of Strategy and Business Development for SolidWorks, Sujit Jain.
Well, good morning. What an incredible way to kick off day 2 of 3D Experience World 2026. What do you guys think, huh? Amazing. So one of the biggest conversations in tech right now is, can AI replace human creativity? And honestly, we think it's the wrong question. Because the best ideas, they always come from people, from vision, intuition, emotion. AI helps us go faster, explore more, but you drive the spark. So today, I'm thrilled to be joined by 3 founders who have taken that spark and built extraordinary things. Companies using AI as the destination, but not as a destination, but as a force multiplier for imagination. So please welcome to the stage Dr. Jensen Huang from Westwood Robotics, Dr. Adil Akhtar from Psionic, and Russell Layton from Sparx Hockey. Hello.
Hi, Sachin.
Hello.
Hello.
Okay, so let's jump in. Zhao, Adil, Russell, thank you for being here.
That's cool.
And we've got robotics, prosthetics, and hockey, right, in one segment. So what could possibly go wrong? Huh? Well, but seriously, let's kick it off. Let's give everyone a feel of what you guys have built. So, Zhao, let's start with you. Westwood Robotics is building robots that just don't move, they adapt. So what makes your robot different from other industrial automation robots?
So industrial automation relies on predictability. We are designing for the opposite, which is variability. So that's why we created our AI augmented humanoid OS, which is a modular stack that coordinates whole body stability, navigation, and safe interaction with consistent behavior. Underneath, the AI is capable of adapt to a new environment or new tasks with minimal data, such as a few photos or a short human demonstration. And you can actually see it today. I encourage you to come to our booth. It's a brand new environment for Siemens, and you can check it out how well she's adapting in real time.
Thanks, Zhao. Adil, you are doing something remarkable. Tell us about the Psionic Hand.
Yes, so Psionic is the leader in advanced bionic hands for humans and robots. Our flagship product, the Ability Hand, is the fastest on the market. It's super durable, the first with touch feedback, and it's covered by Medicare in the US. We have close to over 300, we have actually over 300 humans using it as a prosthesis now, and over 50 robotics companies, including NASA, Meta, Google, Amazon, Mercedes is building cars with them, top industrial, automotive, and brain-machine interface companies using the hand.
Amazing, that's... Russell, you have turned NHL-grade skate sharpening into a countertop product. So what's the magic behind the Sparx sharpener?
So there really isn't magic. There are no tricks. What we do with the product is we put in precision and consistency. When we studied professional skate sharpeners, the people that sharpen the skates from the NHL all the way down to kids, what they're doing is they're using decades of experience to compensate for variability in hardware, a manual sharpening piece of equipment. And what we did with Sparx was we engineered that precision in. So by using constant speed on a grinding wheel, constant pressure, constant translation speed, and sensing the location of the blade, we can turn what used to be a precision operation done by an expert into a consumer product that anyone can have in their house. And the accuracy of the two edges inside on a skate blade following a Sparx sharpening is to 1/10,000th of an inch.
Well, that's amazing, and you've designed a consumer-level machine with pro-level precision. And how has Solidworks helped you bridge that gap from concept to what's now in the locker rooms across NHL?
Yeah, so we started the company over a dozen years ago. We've been in the market for 10 years, and Solidworks, as a mechanical engineer, Solidworks was everything behind the company. And some of the biggest technical challenges that we faced were actually with this small grinding wheel that I'm holding. It's the size of a poker chip. It generates a lot of heat when it's sharpening the skate, and will actually melt the skate blade. So we use thermal analysis inside of Solidworks to design a rotating heat sink that dissipates heat while the skate sharpening is happening. We also use mechanical simulation to optimize the carriage design, which is moving this across the skate blade for constant pressure. And then most recently, we're actually on our third generation of product. We have over 125,000 machines in the world. This third generation has presented the problem of reducing part count while maintaining strength. So with stress simulation, we're able to convert an extrusion and 7 other components that attach to it, machine parts, sheet metal, into a casting, a single part, without losing any of the structural integrity.
Amazing. So a lot of simulation out there. Adil, your story is incredible. You've blended neuroscience, engineering, empathy to build your company. So when did you know this was your mission?
Honestly, I've wanted to build bionic limbs since I was 7 years old. My parents are from Pakistan, and I was visiting for one of the first times. This was the first time that I met someone missing a limb. She was my age, living in poverty, missing her right leg, and using a tree branch as a crutch. And that's what inspired me to go into the field. Since then, I got a bachelor's degree in biology, a master's in computer science, another master's in electrical and computer engineering, PhD in neuroscience from the University of Illinois, and I left medical school to build Psionic full-time because that was more fun, and we could have more impact. Yeah, this has been a lifelong journey for me.
Oh, that's amazing. A lot of degrees out there, huh? Well, you've, so Zhao, you've got this beautiful philosophy around robots being aware of their surroundings, the world around them. So what got you started?
So I have been fascinated by humanoid robots for as long as I could remember. I was 10 when I saw Robot Asimo walk, and I was absolutely obsessed. In 2015, I joined DARPA Robotics Challenge, and oh, this should be a video playing, but okay. So many of you might have seen this video before. It's robot failing at the challenge. Watching them fail was actually a wake-up call to me, and that pushed us to focus on the fundamentals, especially new actuation technology, and also the new control algorithms. And Westwood Robotics grew directly out of that, which is a company that is bringing robots closer to people, turning humanoids into reliable teammates that actually help people.
Okay, so we'll stay with you, right? So these robots are quite elegant, but they're mechanically complex. Right, so how have simulation tools, you heard from Russell, our Solidworks, our cloud products, collaborations have helped you, get them to market faster and smarter?
Yeah, so actually that should also be a video playing. It's a video of Bruce. Never mind, you guys can also come to our booth and check out Bruce in motion. Oh yeah, there we go. So Bruce is actually the world's first kid-sized humanoid robot that can jump and run, and it's all open source. You guys can grab all the files online. So our robots are actually great examples of how simulation helps us balance the stiffness for accuracy and lightweight for efficiency. So we rely on SolidWorks simulation to validate the structure and thermal behavior early before we cut metal. And it allows us to stress test different designs and make informed trade-offs without wasting time or burning time on the physical prototypes. And we also use topology optimization to reduce weight and while preserving the stiffness for our robots. And this is actually very critical when every gram matters for control performance, energy use, and dynamics.
That's amazing. So a lot of simulation out there. Adil, you were part of the SolidWorks for Startup program, and of course you're using SolidWorks, so how has that helped you guys?
Yeah, so we do all of our design work from the entire hand to every peripheral component in SolidWorks. Early on, that meant rapid iteration, changing geometries, testing mechanisms, and getting from idea to prototype incredibly fast. As we scaled, the same platform enabled us to go from lab prototypes to a Medicare-covered medical device without switching tools. For us, SolidWorks isn't just CAD, it's how we bridge human need to real-world scalable hardware. And do you want to see a demo of it?
Yeah, why not, right? Do you guys want something quick? Yep.
So there's an app for it. There's an app for everything these days,
Yeah,
right?
yeah.
So if you put your hand in front of the camera, you can actually control the individual fingers on here.
Amazing, amazing.
You can try that at our booth as well.
Okay, so Russell, what's next for Sparx Hockey?
So for Sparx, we now perform over 10 million skate sharpenings a year, and our current product is actually piping all of that skate sharpening information into the cloud. One of the things that we've learned over the years is that people are very particular about how they sharpen their skates and how they prepare for the game. And with this connected ecosystem of products, we've begun exploring how to improve athlete performance by adjusting the skate sharpening. And so there's a lot of technology out there that's tracking human heart rate and respiratory rate, but nobody's actually combining that back into how we get ready for athletics. And so what Sparx wants to do is bridge that gap and allow athletes to perform better by changing the gear that they're skating on. So that's what we're up to. That's the future. We're also looking at other sports where blades meet ice and snow, like skis and snowboarding, and figure skating.
And thank you, Russell. And Zhao, what's next for you guys?
Yeah, so scaling is the next frontier for West Robotics. We are deploying humanoids that are reliable in real human operation environments into broader, higher impact operations. And for us, that means pushing task efficiency and cost efficiency at the same time, and improving making higher throughput per shift, less downtime, further improving reliability and safety, and also while significantly cutting the cost of using our robots. So 5 years from now, I see robots as standard teammates in production and daily operations. Humans set goals, handle judgment calls, and manage exceptions, while robots take care of the physical, repetitive, and risky jobs with consistent behaviors. And I believe that with our robots, more tasks can be done in an hour, and then at a lower cost per task. And I believe that with our robots, humans can focus on the parts that truly require human intelligence.
Amazing. And of course, Adil. So what's next for you guys?
Honestly, this is really just the beginning. We're moving towards seamless integration between humans and robots. We're directly integrating our hands to the nervous system through implanted electrodes, and we're teaching robots to do tasks from human users, and that's in partnership with NVIDIA as well. And so what we build for humans benefits robots, and what we build for robots benefits humans.
Amazing. So, Dr. Zhao, Dr. Adil, and Russell, thank you. We saw 3 different industries, and none of these founders started with an algorithm. They started with a problem worth solving, a passion, a vision. At Solidworks, this is the future we believe in, where your ideas come first and our tools help you bring them to life faster, smarter, and at scale. So whether you are designing the next great product, restoring a sense of touch, or helping the next generation to learn to build, well, we are here to help. This week, be bold with your ideas and let your imagination lead the way. Thank you. Thank you, everybody.
I'm gonna play with this. Can I can't stay, no? I'd like to play with that. Very, very cool. Nice. Well, thank you to all who came on stage. Those are great examples of how AI can be a multiplier to help bring your ideas to life. Now, if you are new here this year, you are in for a treat, because now it's time for an annual tradition here at 3D Experience World. Don't miss this demo. But this year, the rules have changed. Our tech marketing team has been dropped into the wild with nothing but their wits, their laptops, and the latest enhancements to SolidWorks. Who will survive? Let's find out. It's Don't Miss This Demo. All right, go ahead, Todd.
Welcome to the season finale of 3D Survivor Barometric Paradise. What a season this has been. Competition, humor, emotion. 25 days ago, we stranded 18 engineers in one of the most hostile, unforgiving environments we've ever seen, the office. One by one, they've voted each other out of this game, and now we're down to the final 4 contestants. Mike, a true super fan of not only the show, but also of SolidWorks. Andrew, as engineering manager, he hasn't touched SolidWorks since 1999, but he brings contagious enthusiasm and excitement. Mark has been an absolute beast in the challenges this season, winning a record number. He might be the one to beat here. And finally, it's Tiago. I mean, what's not to love about Tiago? I mean, seriously, the guy's hot. One epic head-to-head challenge remains, and then the final 3 make their case to the jury, who will vote to determine who takes home the title of sole 3D Survivor. Here we go. Season finale, 3D Survivor Parametric Paradise. Previously on 3D Survivor. This season, we've seen some of the toughest physical challenges ever, as contestants had to work together to win immunity or face elimination. Mark's whipping through this challenge. Nice technique. Keep it going, Mark. You got to dig deep. You got this, man. Down to the 2 marks. Your life in this game could come down to this. Immunity plus reward up for grabs. You can do this. Stay focused. You got this. Come on, dig deep, dig deep. Airplane challenge. Survivors ready? Go.
Andrew.
Mark wins his 5th immunity challenge.
What are we going to do at Meaningless Corp to get to where we need on our carousel of fate? We can't supply.
Andy's struggling hard.
Only black and white printing. We have to really cut back on non-synergistic OpEx. Everything circles back, action, deliverables, and ideation, and ultimately.
We're going to need a medic. And there we go.
No, it is very upsetting. It's very upsetting. Let's take a look at the
Windy.
gross metric.
Obviously lost Andy. Andy, the design review board has spoken. You've been suppressed.
Is this just because I puked? I cleaned the hat.
Rob, the design review board has spoken. You've been suppressed.
No more tips and tricks for you.
You've been suppressed.
Nice, real nice.
Brenda, the design review board has spoken. You've been suppressed.
Promise you guys.
You've been suppressed. The design review board has spoken. You've been suppressed. Paul, the design review board has spoken. You've been suppressed.
Ah, shucks.
You know, I've been watching Mike, and honestly, I don't think he even knows what PDM means. He keeps referring to it before running to the bathroom. He's an easy vote out.
I got a PDM, guys. BRB.
I just don't get it.
Since I first met Tiago, I knew I wanted to be in an alliance with him. I mean, the guy is so cool. He smells like smooth jazz on a summer day.
Everyone here is so nice. They keep calling me cool. I mean, I know, obviously, but it's a lot.
I don't know about you, Andrew, but Mark, he's got to go. He's just too good at everything.
Yeah, I agree. I mean, I heard that he never gets rebuild errors, and if he does something wrong, SolidWorks apologizes to him.
Yeah, well, I heard that he doesn't use external references. Instead, the CAD files reference him.
For the final 5, we unveiled the SolidWorks What's New challenges. Here, contestants had to demonstrate their knowledge of the most recent software enhancements, but in situations you'd only see on 3D Survivor.
In SolidWorks, working with configurations just got even smarter. Now, when you change the reference configuration of an assembly drawing view, the bill of materials automatically updates to match that configuration. This ensures faster updates, eliminates manual adjustments, and makes managing multiple configurations simpler and more efficient. For some time now, SolidWorks has allowed users to work with graphic bodies. making it easier to design projects that rely on imported or scanned components. Now, these components can be displayed directly in the drawing views, without the need to convert them into solid or surface bodies. This significantly simplifies the workflow, reduces preparation time, and makes detailing a much more direct process.
Whoa, okay. Referencing the correct version of a component in a drawing or assembly is fundamental to data and lifecycle management. A new server setting allows users the flexibility to automatically download the latest revision of all first-level references during the open operation. Once enabled, each user can control this behavior from the Open tab in My Sessions options. Now, when I open my drawing from the platform, I get additional control over which parts and assemblies load as the latest revision. Instead of replacing all the reference documents manually, the update is done automatically and ready for me to save back to the 3DEXPERIENCE platform to complete the process.
Mark, you've dominated the challenges this far. Let's see what you can do blindfolded.
I got this. Pattern-driven components has several benefits over mating components manually. Now, when you mate a second instance of a component to pattern geometry, such as part-level feature patterns or whole wizard features, the new Pattern Assistant automatically suggests using Create Pattern instead of mates, and can launch the command for you directly. The component to pattern and driving feature are already filled out, so you can quickly take advantage of the improved solve performance and automatic updates. Sketch relations get a great new enhancement with the ability to create and edit relation groups. Simply select more than one entity and add a relation. The group is created by default for collinear, parallel, equal, and co-radial constraints. For all entities in a relation group, a number is added next to the icon to indicate they belong to a particular group, and hovering over the icon of any entity highlights all the objects in that group. When you click on a relation icon from a group and delete, you can choose to just delete the selected relation, maintaining the design intent between the other objects.
This challenge is on. With every new FD of Solidworks, there are new enhancements. Let's see what's new in Solidworks 2026 FD 01. Drawings can now link bills of material columns to PLM attributes. Once you add a new column and select the new PLM attributes as the column type, the property name dropdown displays both default and custom PLM attributes that you've mapped with 3DEXPERIENCE. As expected, the BOM data updates automatically when you connect to the platform, and you can save these columns in your BOM template. Working with threads in SOLIDWORKS just became much clearer. With a new option, you can now show the full description of threaded hole callouts directly in your drawings. That means cleaner drawings, faster understanding, and fewer questions on the shop floor. It's an improvement that delivers big gains in clarity, confidence, and productivity.
And then there's the blindside vote that nobody saw coming. 14th person voted out of 3D Survivor. Manish. That's 3 votes. That's enough. You need to bring me your torch.
Can't believe you guys.
Manish, the design review board has spoken. You've been suppressed.
I mean, he had to go. Doesn't even know what weldments are.
I implemented weldments.
He's mad.
Yeah. It's been amazing. It's been great so far. Congratulations, guys, on making it to the Final Four. You've used your brains, your muscle, some Solidworks to get here the last day. I want you to let that sink in. You have a 1 in 4 shot of winning and being the sole 3D survivor. So Mark, here's, as winner of the last challenge, you're safe from elimination, okay? Pick one person to join you in the final round. The remaining 2 are gonna battle it out for that last spot.
Well, this is an easy decision. I choose Thiago. He's got that burgada.
Okay then, Andrew, Mike, here's how it's gonna work. You're gonna demo potential future SolidWorks enhancements. Just like making fire is essential to survival in the jungle, making use of the latest enhancements is essential to survival in engineering. The better you do with your demo, the bigger the flame, all right? When your fire burns through your rope, your flag will raise. First person to have their flag raised wins a spot in the final 3. Got it?
Got it.
All right, survivors ready? Mike, you may begin.
Exciting new drawing enhancements are coming for everyday users. As model-based definition gains momentum in manufacturing, it's now easier to carry that intent into drawings. When you import model items, you can quickly mark DimExpert dimensions for use in the drawing view. You can also now highlight a note. Just select the text and choose a highlight color, so key callouts stand out instantly. Slot dimensioning got a lot simpler too. With the new option to dimension slot length from arc center to arc center, you get more straightforward, consistent definition with fewer workarounds. And we all know that applying the right symbols to a drawing is critical for manufacturing, and managing these just got easier. The new favorite categories lets you pin your most used symbols so they're always right at your fingertips. All right.
All right, got a little fire going, a little spark, a little fire. Andrew, you're up.
Okay. So I need to make a quick design change to some tube stock. Moving a dimension from 2 inches to 2.5 inches. After the change, I want to make sure there's no way for future updates to be made. Coming soon, SolidWorks will introduce freeze and save, helping prevent changes triggered by rebuilds or configuration updates. If you see the freeze icon, it means the current part or assembly is protected. It also limits what you can do in the command manager. Freeze and save will also be available at the top level assembly, running a full rebuild of all components, configurations, and mates before freezing. If changes are needed, you can still make them manually by unfreezing the file. In this case, I need to add a missing hole, and then I'll just go ahead and freeze it again. Any changes are shown in the tree and can be updated with just a few clicks. Freeze and save improves performance, protects files from unintended changes, and provides PLM-style benefits right out of the box in SolidWorks design.
Fire's going pretty good, I think. I think it looks better.
Let's see it, Mike.
All right. You know, Andrew, your flame is pretty low still. Good thing I've got this generator to keep me warm. There's a warning in the feature manager tree. Let's open the part. Classic. Original sketch plane was deleted, and this feature lost its reference. Coming soon to SolidWorks, you'll be able to repair this easily. SolidWorks examines nearby planes and faces to suggest the best substitute. Here I'll choose the auto repair to automatically swap in the face that's coincident with the original plane. No more hunting for references. This frame looks solid, but I want a sense of bending resistance without setting up a full analysis. You'll soon be able to view the section modulus, which is a measure of how well a beam resists bending, right inside of SolidWorks. That gives you instant design guidance before you move to simulation. And one more enhancement coming very soon. Pattern features with many cuts rebuild much, much faster, which means less waiting and more time designing. Boom.
Mike, your fire got right up to that rope, but didn't quite burn through. Andrew.
All right, it's time to really turn the heat up, Mike. Check this out. So everyone can appreciate faster assembly performance. Coming soon, a new set of icons on the status bar will keep an eye on your assemblies and flag opportunities to improve performance. Assembly performance design guidance goes one step further and helps explain why circular references, mate problems, or complex geometry might be the cause, and what to do next. In this case, it's pointing to an imported spring with a high graphics triangle count. Display states, they're a simple way to view and compare your assemblies. And isolate lets you focus on sub-assemblies or other selections at the top level. Isolate and save to display states, well, that's been around for a long time, but now isolate's getting an awesome new upgrade. Coming soon in SolidWorks, you'll be able to isolate within an isolate as many times as you need without having to back out of the command. And as always, those isolated views can be saved as display states and recalled later for design reviews or use in a drawing view. Here, I'll create a series of isolated views and save each one to its own unique display state. Now, working with downloaded fasteners is common, but they often include detailed threads. Okay, so watch what happens when I insert this component. Automatic hardware detection kicks in and places it into position. And coming soon, SolidWorks will recognize the threads and prompt me to take action with another design guidance helper. It automatically simplifies the part so I can get back to my day job, managing Tiago and approving all those expense reports. Well,
there goes Andrew's flag. Andrew, that means you've won. This challenge is over. All right, Mike. Mike, I'm sorry, you've been eliminated. And honestly, we're kind of all surprised you made it this far.
Come on.
Yeah. Well, hey, let's bring out the members of our jury. Mike, please join them as the final member. Okay, now the power in the game shifts. 5 people you had a hand in voting off will decide your fate. Okay? Remember, they'll be voting for who they think should win and take home the title of Sole 3D Survivor. You want your name to be written down this time. Tiago, you're up first. Why should the jury vote for you?
Well, for one, I'm Tiago. I'm from Brazil, Latin America. You know that. And on top of that, I kept our alliances tight with the best collaboration tools available. So let me remind you of some of the top enhancements coming. Well, collaboration is essential in engineering. In my team, we use the 3DEXPERIENCE platform. So instead of sending emails back and forth, we use comments. Soon, you'll be able to access them even more quickly with a new Comment Manage button. Looks like my boss Andrew here sent me a markup to review. That's fine, I will reply and just get started. Also coming soon, you'll review existing markups right here inside SolidWorks. No need to open the browser, no context switching, everything's here. So, I can see the latest one showing that we need to fix the sharp corners. Looks like we can also improve the lateral speed of this machine as well, and breaking the sharp edges would be a good idea too, right? Coming soon, you create a task directly from the Comment Manager. Assign a task to a teammate like Mark here, or even invite someone from outside of your company. I will just drag and drop this component from the Feature Manager, and that's it. I can access all my tasks inside SolidWorks as well, so that easy. Looks like Mark already completed the changes. That was fast. Coming soon, you will be able to create 3D markups without leaving SolidWorks as well. Again, everything's here. So, this new hole diameter, let me see, looks good. I can use a visual comparison tool to show before and after of this design. Mark added the large fillets to this corner. Okay, he did. He chamfered the sharp edges. The hole is larger. Wow, it's done. So that's simple. That's collaboration. Fast reviews, easy to share information, all of this without even leaving SolidWorks. And if I had a microphone right now, I would drop it.
Nice job. Nice job. It's so cool. So cool. Mark, now's your chance. You must convince the jury.
Well, jury, not only did I excel at every challenge, the paper airplane, the stapler shootout, the coffee race, the parachuteless skydive, the anaconda wrestling, you guys remember that one, right? Yeah. But I've also shown my expertise in SolidWorks, and one of my favorites comes to mind. If you've ever waited on a stack of drawings to rebuild after making changes to a part, you're gonna love this. I need to add a few holes and fasteners to complete this assembly. An assembly-level whole wizard feature is the best option here because it allows me to propagate the cuts to the individual components. It also makes generating and mating the appropriate fasteners easy with the Smart Fasteners feature. None of this is new. But at this point, we have several existing drawings that need to be opened, saved, to reflect these changes. Coming soon to SolidWorks, users will be able to automatically update drawings as a background process. In this case, the 3 modified components are identified, then the drawing is updated and saved in the background, allowing me to continue working on anything else. Productivity like this is exactly what gave me so much extra time to practice and win so many challenges.
Okay, Andrew, you're up.
Well, you know, Todd, I've played a really honest game and all season, and I think of all of you.
Well,
as family.
I mean, okay, look, we've kind of heard enough of that. Let's just get on with the demo, please.
Oh, okay. Well, you know, the future of sheet metal design in SolidWorks is utilizing the design assistant to help with tedious or repetitive modeling tasks. While a sheet metal part is being designed, the design assistant will offer suggestions if adding weld beads or tab and slot will help the designer. Let's try adding some weld beads. Using machine learning, the design assistant has identified 2 locations where weld beads could be applied to this enclosure. By clicking location 1, it'll automate the tedious task of selecting all those edge pairs and build out the weld bead paths for me. I can still go in and change the default weld bead size or any other parameter before I finish the command. Now, the design assistant understands that there's still a location where an additional weld bead or tab and slot can be created. Let's try tab and slot this time. It knows that there's only 1 location remaining to add tab and slot, and clicking that will create all the tab and slot groups automatically. What a time saver. Now all I need to do is click each group and dial in the tab and slot scheme, the sizing, and the spacing. And we all know, no design is complete until it's been validated. And this is especially true when parts are sealed tightly. Here, we're evaluating how bolt tightening creates a reliable seal between 2 joined pipes. So I'll add some virtual bolts to the clamp. In many pipe clamp designs, you tighten until the pipe just slightly gives, letting the mating surfaces fully deform and create a tight seal. Coming soon to SolidWorks Simulation, you'll have the option to apply bolt preloads gradually, instead of all at once, so you can review the contact and deformation throughout the entire study. For this example, I'll ramp the bolt preload gradually through the analysis until there are no other loads present. In the result, you can see the pipe ends close the gap and form a solid seal as the bolts reach that targeted preload. Boom! And now that is how a true 3D survivor designs.
Oh, nice job, nice job. Nice enhancements, nice demos. What do y'all think? All right, now it's time to tally the votes. There you go. First vote. Tiago. Second vote. Tiago. 2 votes, Tiago. Third vote. Mark. All right, 1 vote, Mark. 2 votes, Tiago. Next vote. Mark, we're tied. 2 votes, Mark. 2 votes, Tiago. 1 vote left. Final vote. And winner of 3D Survivor Parametric Paradise, Tiago! Yeah. All right. All right, that does it. We have our winner. Thank you, Tiago. Thank you, jury. We had a great time. We hope you enjoyed it as much as we did. Well, even though they didn't come out on top, this season certainly made a lasting impact on all the contestants. Let's hear from them now as they recap their most memorable enhancements. John, you certainly laid it all out on the line. What stood out to you?
Oh, thanks, Todd. You know, I had a few. There were a couple I really liked. The configurations now driving BOM updates automatically is fantastic. Big time saver there. Imported graphic bodies can now be shown in drawing views. That's very cool. And then open documents with the latest revision of a first level reference is now possible.
Great. Now, Chloe, you certainly had
what I would call an emotional exit on the show. What stood out to you though, and what did you take away from it?
I love that design assistance helps determine when to use a pattern-driven component pattern. But another huge highlight for me was definitely creating sketch relations with multiple entities with enumerated changeable groups.
Andy, I'm glad to report, you made a full recovery right after that, I guess, upheaval of an exit. But I do want to hear from you now. What were your favorite enhancements of the season?
I would say like how much efficiency I was able to gain by directly linking PLM attributes inside a BOM was pretty huge. And then, also in drawings, like being able to have that full thread description right in my callouts, fantastic,
Now, Brenda, you put a lot of hard work into this season. Tell me what stood out to you.
The new favorites catalog and drafting symbols library helps me to quickly access my most commonly used symbols. I love that I can draw attention to important notes with highlighting.
All right, now, Mark Martel, tell me what stood out to you.
Well, detailing slots now supports arc-centered to arc-centered dimension callouts. That one's a small change, but it's a big finally. Quickly repairing issues when a plane or face ID is changed. Todd, if you ever had a model go sideways for no good reason, you know why I love that. And letting SolidWorks calculate section modules for you with just a click, one click, instant answer, and you move on with your life.
Great stuff. Now, Paul, look, I got to say, you were probably one of the favorites going into this season, but you didn't make it that far, honestly. There had to have been some things that stood out.
Well, I'm glad I was someone's favorite. As far as favorite features, I would have to say increased performance in pattern cuts, because I do a lot of patterns and a lot of repeated features. Design guidance when working with large assemblies, and lastly, isolate parts and assemblies when in an isolated view.
All right, thanks, man. Now, Mark Johnson, I'm sure you can't wait to point out one of these new enhancements to someone on support to help them solve their problem.
Thanks, Todd. Yeah, we're all about performance here. So I'm super excited about the new performance design guidance and how it helps you find unnecessary threads when you're importing fasteners. I'm also really excited about how you can create tasks and manage markups without leaving SolidWorks itself.
Cool. Now, Brenda, I'm going to go back to you. As one of the fan favorites this year, bring us home with some of these last enhancements that were really impactful.
Auto update on drawings. Staying productive while SolidWorks is updating drawings in the background. Great. Design guidance for welds, tabs, and slots. Nonlinear preload for bolts. The preloads can be applied gradually when using bolts in nonlinear studies, and I just love that.
Thanks for recapping those enhancements, everybody. And thanks so much for your participation on the show this season. It was one of a kind.
All right, and thank you. Don't miss this demo. As informative and entertaining as ever. Well, it's been a full day of AI tools to help you bring your ideas to life faster, smarter, and at scale. Outthink, outsketch, outdesign. Well, I hope you had fun at the meetups yesterday. Don't forget there is a mega meetup today at 5 p.m. And of course, it's special event night. Woo, that's right. Now the buses will leave from the Lamar Street South Transit Center starting at 6:15 until 7:15 to the Houston Space Center. And make sure you bring your badge. It's going to be a fantastic time. I might say it's going to be a blast. So have a great day, and we'll see you tonight.
We're live.
They voted off my favorite contestant. What is wrong with these people? 3D Survivor, everyone. Part of showing off what was new in SolidWorks 2026, or what is new now, but also SolidWorks 2027, which we'll talk about a lot tomorrow. But this stream is not over. We're talking a lot about new technology, workstations, of course. So we have Jonathan Patton here from Intel. Jonathan, what's going on, man?
Hi, how's it going, everyone? So yeah, Jonathan Patton here for Intel. I'm here with Dell. We're here to launch our latest Granite Rapids workstation platform, Intel Xeon 600 processors for workstations. So we're super excited. These are like heavy-duty workstations for like simulation work, visualization work. So it's awesome. I'm super excited to be here.
And Jonathan, so part of this segment, and talking to you, so excited to hear what you are working on, but part of the segment, I'm going to be looking at my phone. I am watching the YouTube chat. So those of you who could not be here, we have a lot of people kind of coming out from general session, watching along with this segment here. But if you have questions about workstations and technology as we go, please ask us in the live chat on YouTube, okay? So Jonathan, tell us a little bit about what brings you here to 3D Experience World.
Yeah, yesterday we launched our new Xeon-based workstation.
Wait, you launched something at 3D Experience
World?
Yeah,
at 3D Experience
awesome.
World. Yeah, we're here with Dell to talk all about it in their booth. We have a bunch of education sessions. I did a breakout session yesterday talking about the differences between Xeon platforms and Core platforms for workstations. So on Core-based workstations, like our Intel Core Ultra processors that are in Dell's Pro Max workstations there, they are really good for SolidWorks use and latency-based sensitive work there. Whereas our Xeon-based workstations are there for more simulation work, heavy-duty computing there. So it's awesome. I'm just a fan of workstations and SolidWorks in general.
I love that you brought that up because Jesse and I just and a lot of you know this already, but we are on YouTube a lot. We are doing live streams quite commonly. We just had our What's New in SolidWorks 2026 launch live stream. We do SolidWorks Delivery Day, new updates throughout the year. And a lot of times, it doesn't matter what the topic is. Somebody will come in and they will ask a question about workstations. Which workstation is best?
Yeah.
But it's a hard question, and there's always some derivative of that you have to answer, right? Yeah. So can you talk a little bit more about that, because that needs to be talked about again and again. Like I can't answer that question because it depends so much on the nature of your work, right?
Yeah, exactly. We kind of have a philosophy about the right tool for the right job. You wouldn't use a hammer for a screw, and you wouldn't use a Phillips head screwdriver for a nail.
Definitely
right?
shouldn't.
Yeah, it's definitely, you have to have the right tool for the right job.
Everything's a hammer if you use it wrong enough.
I mean, yeah, anything's a hammer if you use. Yeah, that's right. Yeah, you can use the handle. But yeah, no, definitely we have that like kind of philosophy of the right tool for the right job, and that was what we talked about at length for like a whole hour in our breakout session. Was, hey, if you're using like SolidWorks day in and day out, and you're doing CAD CAM modeling, and your assembly can fit within the memory constraints of that platform, up to 256 gigabytes of memory on that platform, that's a great platform for you, both in mobile platforms and in desktop workstations as well. And so we kind of talked about, hey, if your project assembly and your models are getting larger and larger, and you can't fit it within that platform, that's where you start working up to Xeon-based workstations, where you have more memory, you have more bigger and multiple GPUs there as well. These are heavy-duty workstations are for that simulation, Simulia type work as well.
So how do you recommend somebody do that, right? If they're sitting at their desk and they suspect, okay, I suspect I need a new machine.
Yeah.
Should they pop open Resource Monitor and try to figure out what's using what, based on, they may not know the behind the scenes of what their software is actually using in terms of system resources. What's a good way for them to do that and figure out, okay, maybe this particular system is a better fit for me than another?
Yeah, I think a great start if you're in Windows is opening up Task Manager, have it on a second screen, and then just go about your day doing your normal work. Hey, I need to do an FEA simulation, or if I need to do some fluid dynamic simulation, or if you're just doing regular product design and modeling there. And just kind of look at the system resources, see how many cores are being used, see what your memory usage is, as well as see what your GPU usage is as well, to see, hey, where am I limiting at? Like if you're seeing stuttering in your workflow, and you look at your task manager and you're saying, hey, man, I don't have enough system memory, it's maxing out. Maybe it's time for an upgrade and looking at different workstation platforms for yourself. Yeah.
Makes sense.
So tell us about you mentioned the new workstation launch, right? So we're talking about the general differences between Xeon platforms and core desktop platforms, but tell us about the launch that happened.
Yeah, so we announced yesterday and we released all of our information to the press talking about, hey, all of the great performance we have on Granite Rapids Workstation. It's a code name. So they're named Xeon 600 processors for Workstation, and they'll be coming to platforms like Dell later on in March here, but we're actually wanted to launch here because we so understand that the Dassault software can take advantage of Granite Rapids Workstation. So we have up to 86 performance cores on our Xeon-based workstations. So that's a lot of cores for heavy-duty computing. We also have some new AI-based acceleration built into every core. It's called Intel AMX, and so that's really great for denoising ray traced images. So if you're in a SolidWorks visualizer, that's using a CPU-based ray tracing engine, and so when you're doing CPU-based ray tracing, it's going to be very noisy. And so we actually enabled AMX, or advanced matrix extensions, to accelerate denoising of that with our open image denoise technology that's actually going to be in Stellar Physically Correct and 3DEXPERIENCE and a whole bunch of other different software products coming from Dassault in the coming months here. So
that's cool. It gives you a lot of flexibility. I mean, even if you had a really great GPU or something, it's great to have that on your CPU too, because you've got the flexibility depending on what you need.
Yeah, and the heavy duty or the high-end workstations are there for configuring to what your workflow is, whereas a general purpose kind of desktop or mobile workstation is there for a lot of vast users, to 80%, 90% of the users there, where the heavy duty high-end workstations are really there for those specialized users, really there to custom tailor fit to accelerate their workflow, because if they're more productive at the end of the day, the business does well. Right.
Yeah, it's great to have, like, hear you say that flexibility, because a lot of times I'll have, a customer that says, okay, I do a lot of simulation, but I also want to occasionally do some graphics work.
Yeah.
And that's a great case where you might want to go towards a system that's more set up for simulation, but then you've got things like the denoising that can also help you out on the back end too.
Yeah, definitely. What we kind of, right tool for the right job as well, we kind of say, hey, if you're just doing day in and day out that architectural design, product design, that's where our core-based platforms are. But if you're doing that plus visualization, plus rendering and simulation, plus even reality capture, and you're doing all of that on the same workstation, that's where the Xeon-based workstations are really there for. So it's like the right tool for the right job. You don't want to buy things that you don't necessarily need for your workflow if you're just doing that kind of SolidWorks type workflow there.
So I'm seeing some people in the hallway. Just man, this is the most distracting seat in the house, I have to say, but in a good way. I wanted to, so Jesse, a lot of the renderings that we see, especially during launch season for SolidWorks, which is all year round really right now, but particularly when we launch that first release of a yearly release, a lot of the renderings are renderings that you're doing. And one of the things I find so fascinating is that when we talk about AI, a lot of times we talk about the things that we directly engage with, software that is stated to be AI.
Yeah.
But we know, if at least two of us know from SolidWorks usage, right, that a lot of times the integrations that we hear about are things that maybe are happening in the background, right? And we feel the performance boost. So can you talk a little bit about this from a visualized standpoint, sort of that interplay where, again, AI is sort of powering performance boosts that we might not exactly see. Like, where have you kind of seen that?
Yeah, it's an interesting thing. It's been fun. I have a pretty cool seat, not just in the conference, but in what we do, in our day-to-day, because I kind of get access to behind the curtain. So it's always fun to chat with the developers and things like that. There are, on the graphic side in particular, there's some really cool things coming along for that in terms of AI, just in terms of creation at like every level, which is really neat, right? You can create with AI textures, you can create whole images and everything in between. So I'm really excited to see what comes of that as we come along. I was just talking to Bastian about that yesterday or day before while I was here and I were chatting at a round table. So it is really cool, and it's a very interesting time in creation in terms of computing, because there are now suddenly so many different options, right? You guys are releasing your crazy CPUs, and there's crazy GPUs, and then there's cloud, computing options. And it's cool to see so many options available on the table that you can really fine tune, to your point, or you can get a generalist machine that will also do pretty well at, especially compared to just a handful of years ago, will do extremely well in any kind of test that you would need. So yeah, it is an exciting time.
Yeah, there's just an explosion of compute options. And even though we're launching Granite Rapids today with Xeon 600 processors, we also did a big launch at CES as well of our Series 3 Intel Core Ultra, so codenamed Panther Lake if you're more in the tech sphere.
That's a great codename.
And so that's coming to workstations as well, kind of in the March timeframe. We're not launching it today, but I'm super excited because that will bring huge amounts of built-in graphics into the CPU there. And so you can have smaller and thinner workstations that can do things that you needed a discrete graphics before, like an NVIDIA graphics. So yeah, no, we're super excited about that.
Yeah, that is fascinating just in itself, and kind of lends to what I was just saying. It's like a lot of times I feel like these days you're using a CPU almost to do what a GPU was doing in the past, and vice versa.
And
GPUs
vice versa.
are now doing what CPUs used to, which is really interesting.
Yeah, there's a bunch of compute options, and it's just we're in this age of AI. We're in a choice. There's a bunch of different choices depending on your workflow, and it's always a conversation about, hey, what the right tool for your right job is. Yeah.
So I want to check in with you as well. We talked about the interoperation between software, hardware, AI hardware, but there's also this very human interoperation, right, between our partners, right? So Intel and Dell. Can you tell us about your work with Dell?
Yeah, working with Dell is fantastic. Like, they're amazing to work with, and we're here in Dell's booth to kind of talk about our new Xeon-based workstations and talk about this kind of Core and Xeon dynamic there. And so we're super excited to announce that, hey, it will be coming to Dell Pro Max and Dell Precision workstations coming in March timeframe. So yeah, they're super great to work with. We love partnering with Dell, and it's always a great time to kind of talk to end users as well. Because we don't get to do that too much. Dell's always the one you call, like, hey, I need help with my system that I bought from you. But it's always great to kind of hear direct feedback from users of, hey, I really would like to see something in the future, some kind of CPU that could do this or could do this. And what's funny is there's a lot of overlap between the Dassault software users and the engineers that we have at Intel. Silicon design engineers, thermal engineers. I actually brought some step files for our thermal design for Granite Rapids. So we actually provided some reference designs to our customers. And so I brought them here to kind of showcase to end users like, hey, this is the engineering that goes inside Intel. Like really cool thermal engineering stuff and simulation work over that, yeah.
Well, Jonathan, respectfully, get out of here.
Okay.
We have 4,000 people on site here.
I know.
And so many people that could be helped by your expertise. Thank you so much. Anyone who's listening, Dell booth, go to the playground right now. But those of you watching at home, Jonathan's a great guy. Thank you so much for joining us here on Live.
Thank you. Wonderful.
All right.
Bye.
And hey, we are not done yet. We're going to contextualize the day's events in just a moment with the great Tracey Wilson. We'll be right back.
Dell Pro Max and Dell Pro Rugged. Find us at booth 210. Speak with Dell experts and our partners from Intel, NVIDIA, and AMD. Experience in-booth demos featuring Dell Pro Max laptops, towers, and Dell Pro Rugged. Dell Technologies.
right, well, we are back once again to wrap once again on day 2. Which,
yeah.
Again, feels
Day 2.
impossible.
I know. It is crazy. Sorry, I was distracted. I got some more stickers. Got my
swag
3D Survivor sticker. Right?
How much did you love that? Outthink, outsketch, outdesign. If you're a fan of Survivor, this sketch today from Don't Miss This Demo General Session this morning was hilarious.
It was very good.
You do run out of space, though, guys. You do run out of space. I have an Awala water bottle, as many of you probably do at home. I have some space right here, but so many stickers that I got here at 3D Experience World. Yeah.
Well, Sean, you did promise yesterday that you were going to bring the water bottle, so I'm glad to see it. The unveiling of the sticker on the water bottle.
Yeah, as we go here, I'm just going to add another sticker in honor of my favorite TV show, 3D Survivor.
That's awesome.
Outthink, outsketch, outdesign.
Right, it's so good. And
got it.
I don't know if you saw this morning, but yesterday on this show we said, hey, we talk about our first timers, but have we talked about the second timers? Like, let's talk about the people who came back. And so I did.
Yeah,
I said it's day 2, so let's shout out the second time. And it was fun.
I love that.
And I thought it was so great because it is, like, I think we honor the people who come the first time. We talk about them a lot.
Yeah.
And then we talk about the people who have been coming for years and years. But it's like, hey, you came back last year and you came back again because you kind of bit the bug. You get the magic. You know what 3D Experience World is. So once you come, I think you continue to come every single year.
Yep, we talked about it.
Yep.
A little bit of the pre-show today too.
Totally. Yeah. But hey, I'm excited to talk about General Session. I know a lot of you were very excited for General Session. We'll talk more about that. I have some numbers I could even share. You guys love numbers. We love numbers.
We love numbers.
But yeah, let's get into it.
Let's get into it. Let's get right into it. Well, of course, I mean, are we going right to special guest?
Oh, we have to.
You have to. You have to. Get right to it.
Jensen, I'm assuming?
Yes, we're talking about
Jensen
Jensen.
Huang. Yes.
I will say that backstage today, he did put on one of the sparkly cowboy hats.
Hey,
he
how
was
about
game.
that?
He was fun.
That's awesome.
You know, when you see someone so big and famous and just so renowned in their speeches everywhere, their big events, you're like, oh, I wonder what they're like in person.
Yeah, sure.
He was kind of amazing.
That's
he was
cool.
kind of amazing. And I will say,
very relaxed.
what was hilarious when he came out on stage, he said, I am definitely a solid worker.
Yeah.
And it got a huge joke. And we're like, that guy is definitely a dad.
He knows his audience as well.
He knows his audience. He knows his audience.
Yep.
That was a lot of fun. Of course, we could see some video of him up on stage. And what was your biggest takeaway, both of you, for what you saw? I mean, you probably know a lot already of what he stands for, what he says, but what was your biggest takeaway about him today in General Session with Pascal?
I kind of liked how they started it with, like, this isn't a brand new partnership, right? We've been working together for so long. But I kind of liked how it's like, well, Dassault has been a visionary in this area for forever, right? They were talking about the virtual twins and all of that. And it's really just kind of a convergence at this point more than it is, you know, some kind of planned partnership. It just sort of makes sense that it's now at the point where all of this has come to reality, which is amazing. It's super exciting for us.
I think sometimes when you listen to keynotes, you sort of have this crystallization moment, right, of the things that you may have been thinking about but hadn't fully realized or expressed as well as maybe it occurs on the keynote.
Sure.
So one of the things he was talking about was that if you look inside of his email inbox or any of our email inboxes, right, just as an example, you have, a summation of 30 plus years in his case of experience.
Yes.
And so that almost in itself can give you some representation of your knowledge and of who you are. And if you were to take even a combined look at like my prompts over time inside of an AI engine, it can make a companion, right, that can actually help me and understands me and can assist me with my tasks. And the way that he said that I thought was interesting. It isn't like search where it's like, oh, I have a search history. There's no aggregate sort of result of that. I can look back at it and maybe, oh yeah, weird. Back in December 12th, of 2025, I searched for this. I don't even remember that. No. Using these specific systems over time actually becomes more helpful because of what we're actually training it on. So the way that he said it stuck with me.
It's a cumulative effect.
Yes, exactly.
Of you.
Of you.
Is the important part. The cumulative effect of you, not of Googling something, but searching your own emails and saying, what is the cumulative effect of you, of what you have said, of your knowledge base?
Yeah. And over time, that makes our companions solid workers.
Yeah, solid work. That's right.
Yes.
Put that on a T-shirt.
I'm sure it already is.
It probably already is. Makes our. But again, like we said yesterday, I also love to continue to talk about there are companions.
Yep.
Yeah.
That there are companions.
Yes.
I think that's really important.
Yeah, and I think Manish talked about that a little bit too, about that cumulative effect, how you've got all of this tribal knowledge throughout your company, right? That you may or may not be able to access in your own mind, let alone the minds of everybody else that is working alongside you. So you're kind of growing that mass of tribal knowledge that you've got that you can then apply reliably every time.
Well,
it's really cool.
I also loved when Manish said that AI is just a tool in your toolbox,
yes.
right? It's not replacing you. It's like you are still the driver. You're still the creative. You are the one that's going to be making the future with AI.
Yep.
Like, it's your toolbox.
100%. Yeah. I mean, that's how I feel, and I mentioned it yesterday during the recap. You know, hopefully, being able to see that is our approach. That is our outlook on this right now, right? That to have companions that are working alongside you, making your work better. As a partner that's always there, I hope is of great comfort and gives you great optimism as well as far as capabilities.
Yeah. Well, I think another thing that was really great about General Session today, as always, is having customers up on stage. Having real life customers who are saying, this is how we use SolidWorks, this is what we're doing, this is how we apply it to our companies. And so we had 3 great different, and we're going to see some of them right now, I think, on some of our B-roll as well. But one of the things that I love about 3D Experience World is we see these customers up on stage and we hear about them, it's very exciting, but you're at a huge convention hall. But then in the 3D Experience Playground, you have an opportunity to walk around and see these customers and look and touch and learn real firsthand, literally firsthand, right? When we're talking about some of the things. Then you can say like, oh great, and you can talk to the CEOs, you can talk to the engineers, you can talk to the users of these products in real time and ask them questions and have a really like impersonal opportunity to meet with them.
Yeah, and the stream had everything, right? The stream, general session overall, just to focus there, whether you're in person or you're watching at home or in your office, the stream today had everything.
Mm-hmm.
And I had to say, I brought some metrics, like 1.4 thousand, over 1.4 thousand people watching concurrently today, which shattered records in SolidWorks history. Like it was by far the most popular stream in SolidWorks history. So I wanted to thank you guys for that. We got special looks at a lot of these customers here at the live desk as well, which was awesome. So being able to see all these innovations up close and in person, and also talking about, and we mentioned this with our partner over at Intel, Jonathan Patton. So we came by the integration of AI within hardware and actually seeing real examples of that. This isn't something we're talking about 3 or 4 years down the line, something that's being worked on right now, like actual integration. I think it's super cool.
That's fantastic.
Yeah, I think you mentioned access, and that's one of the things that I really do love about this conference. It seems like it's almost unparalleled access, right? We obviously have the show here. If you're watching with us online, that's great, but there are a bunch of chairs that we're looking at right here, right? You can sit with us, you can watch us interview people. On stage, right, you can see their keynotes, but like you said, you can walk right down the hallway and you can talk to all of the people who are here. And then of course we've got the Hive and our events. We very intentionally build in networking areas.
That's right.
Places where people can meet. It's a very people-centric event, and it always has been. But I do really love that about this event, and I'm glad you brought that up.
Yeah, we have meetups and we have mega meetups.
Yeah, I'm going to one tonight.
That's right. That's right. So let's talk a little bit about some of the customers we did see on stage. So I know Psionic was one of them, the Psionic Hand, and Dr. Adil Akhtar, the CEO and founder, was on stage, and also Dale Damasi is here, one of the users. And it's really incredible. I know we're going to show some of this to see if you weren't with us today, if you didn't see the live stream, you can see now how phenomenal this is. And the ability to have a hand that you can use if you have had an accident, if you're born without a limb, that you really can. It really was incredible to see how they connect it, how they use the nerves as it was really quite remarkable. You could see it the way that it lights up. He was showing all the different mechanics of the hand.
Yeah, it is really fascinating. I got a chance to talk to them at the desk, and he brought his little app system that he was showing on stage, and he blew me away. I didn't even know that he had that with him. He just held it up, and he's like, "Hey, put up your hand." It's crazy how reactive that is.
It's really reactive, and I thought it was interesting. I mean, you can't see on the desk right now, but like I've had an injury to my arm, and it is. We talked about this a little bit yesterday. It is very hopeful to say, "Hey, you know what? Like, accidents do happen, things happen to people, but now there is a lot of hope to say, yeah, this might not be how you intended, but guess what? We actually have a hand for you. We're going to give you a hand.
Yeah.
But you can and actually do that.
That demo we just showed with Suchit on stage, that had to be one of the coolest shots that we've ever had of a demo. You know, Suchit actually holding up his fingers and the identification and then sort of replication.
It totally
on the
caught
arm.
me by surprise. It was
Yeah.
really cool.
It was really that type of thing. It can make you very emotional.
Sure.
To think about how using engineering, how using SolidWorks software to do such good in the world and such good for people is really overwhelming.
Yeah, and it amazes me. Obviously, they work with Dale, and who he uses the arm himself. But it is amazing, you know, thinking about what you were saying with your injury and like people who are in the place where they get injured and then develop the solution.
Right.
Like, your excitement that there is a solution, you know, for those type of injuries. But you know, people like Christian we've got here, and all sorts of people like that you know, have something happen that they need to innovate their way out of and do, and then come
Innovate
and share
their
it
way out of.
and you know, share it with everybody. It's amazing.
I like that, innovate their way out of, and they do.
Yeah.
Right? And another person who found a need and filled it in a kind of fun way is Sparx Hockey, right? So Russell Layton, the founder and CEO, he said, you know, everybody's playing hockey or ice skating, and it's really hard to sharpen those skates. And so he made this amazing machine that is both commercial and consumer. So you're gonna find this in the NHL, you're gonna find this at different skate rinks around the country, but also if you are a kid who's very into hockey or very into figure skating, you can have this yourself.
Yeah, we should say, I mean, all these different products and solutions, they're all designed with SolidWorks, right? I joked at the desk, that's sort of the lowest common denominator, very important lowest common denominator, by the way, but it's SolidWorks design. Russell showed using SolidWorks Motion as well. So yeah, real problem solving happening. And I think their video where they show the skate sharpener we had at the live desk, it's super portable. It feels like it's like a Cricut or like a you know, an HP printer, it's like a 2D paper printer. The window is so small, you can have it. It could be you know, at a rink. You can have it on an entryway table at your house if your kids are doing a lot of skating or ice hockey playing. So yeah, pretty incredible.
I imagine if you're like the one hockey kid of like all your friends, or like the hockey mom or dad, who's like, oh yeah, well we actually, you know, we have the Sparx hockey skate sharpener at our house. You'd be like the coolest kid, like all the friends would be like, oh, we're going over there to sharpen our skates.
I was telling Russ that my brother-in-law has one, so all my niece and nephews, they were sharpening their skates for me and showing me. It's really cool. And they take it with them when they travel. They just pack it up, take it with them.
That's
Very
incredible.
Cool. Yeah, we had other guests at the desk, and of course we saw Westwood Robotics.
Yes,
right?
yes.
Let's talk about Westwood Robotics here. Dr. Zhang, crazy. I told him right after our interview that his ability to be able to explain complicated topics such as robotics and robots actually interrelating with humans, right?
Yes.
In these regular spaces it was unparalleled. So I was so impressed by him.
Yeah, they had Bruce on stage. Of course, Themis also in the playground. So you can have an opportunity to see those as well if you were here in person with us at 3D Experience World. But yeah, he was pretty great. It's pretty great. And I always love, we talk about this a lot, I always love when you're backstage, you get to also kind of like casual chat with people is always kind of neat, just to talk about like their excitement about being here and their excitement about sharing their engineering marvels with SolidWorks. People are very excited to share what they can do. There. Oh yeah, there we go. We see Bruce right now. Okay, and that Themis waving at us. Pretty neat.
It's quite incredible. Like Jesse, you were talking about the different material selections. Yeah. And we were talking about just the overall weight of the robot and the portability that he's been able to achieve. Yeah, lots of marvels in terms of these two distinct robots.
It was interesting to hear him talk about too how he kind of used that aesthetic in the design language and all of that to kind of be disarming, right? He was trying to make the robots feel comfortable, which is a cool area of focus, and obviously something that will continue on, I'm sure, as we go into more and more robots appearing in more and more places, and people are interacting with them we're used to seeing robots. We see robots here all the time. Yeah, right. For the general public, maybe not so much.
Yeah, the general public sometimes might be more afraid of like a humanoid robot, or say like, why did you have to make it look like a person? Or like, it's like, where is we're gonna make this look exactly like a person, or like, we know that it's a robot, but we're gonna make it feel comfortable and sort of familiar.
Yeah, and it was interesting to hear that was a focus of his.
Yeah, I like that.
So what are some other areas of general session that you guys really liked?
Well, I mean, we did talk a little bit at the top about Don't Miss This Demo, and it really is a crowd favorite. They really do such a fun job of showing about the latest enhancements to SolidWorks, a fun and entertaining and engaging way to do it. I always love when the audience oohs and ahs when they see something new and excited about what's coming next and the next releases of SolidWorks. I always think that's very exciting. This year, the Survivor theme, very fun.
Yeah.
But not only are they fun and entertaining, but there's so much joy around it. There's so much joy. You can see the joy of people coming in right now, the joy of people coming into the doors and grabbing their seats. There is a lot of fun and excitement here.
Yeah, we see some certification testing, no doubt some
very important.
On. Yeah, that was a huge focus for a lot of people that came here on Sunday. Avelino, who works on the certification team, is here talking about that. He had a very busy day on Sunday with so many of you. I'm sure if you're rewatching it, if you attended in person, but yeah, very big focus. But you mentioned 3D Survivor, don't miss this demo, right?
Yeah.
Manish got voted out.
Oh, I was going to say Manish got voted out. I thought that was hilarious.
How about that?
So if you haven't watched it, you got to rewatch the stream because I thought that was, you know, to have the SolidWorks CEO voted out of Survivor was a pretty good joke. It was pretty funny.
Yeah, they really have a cult following going with that.
They really do.
That program. I was talking to Brian Zayas earlier.
Yeah.
And he was showing me a picture of the CSWE event last night, and he was showing me a picture of someone dressed as Platform Jones who had taken a picture of Mark Peterson, who played Platform Jones, if you're not aware. And he was telling him about, you know, some of our previous skits, and he was like, "Give me your email. I'll send you some good watching." So.
Well, because even when I started with this event in 2017, I was so excited to and that year we did America's Next Top Modeler was the event, right? Remember that? And it was so fun for me to go back and watch all the years before and be like, this is amazing. This is a lot of fun. I was so proud to be a part of it a couple of years too. It's a lot of fun. It's a lot of fun.
Yeah, and I'm excited for, and I should say before I start plugging tomorrow, do you guys have any more thoughts to share here?
Well, I mean, I know we're going to run out of time for this, and I know you have a lot to say, but of course, if you're with us at special event, I'm going to the Houston Space Center because there's going to be a party, and it's going to be a blast.
Yeah, look at this. Look, I have my sticker right here.
I show it right there.
Houston, we have a party. There we go.
It's so good.
Yeah, I got this actually in the playground. We have, those of you who are 90s kids, I guess, like myself, you remember, they had the little coin and the turnstile. You get the stickers that come out. These are nice die-cut stickers. These are awesome. So I'm very happy to have this, and also very happy to be joining in the special event.
Yeah.
You can't get much cooler as far as an event venue than the NASA space.
You really can't.
You really can't. You really can't. Well, I know you have a lot to say about tomorrow, so we'll let you get to it.
Yeah, we're not done, right? So we have a stream that I know you all will love tomorrow. So we talked about Don't Miss This Demo, the skit. You see a little bit, you see a good bit of explanation up there as far as the sort of consequential nature of a lot of these features to SolidWorks users. But we're going to be doing a deep dive at the desk with skit team members out of role.
Sweet.
Yeah, so it's just going to be us in our normal technical roles talking about the software. So don't miss that. We'll have Model Mania winner reveals.
Fantastic, yes.
Hopefully some model reviews with some of the winners and finalists here at the desk. Of course, we have day 3 general session, which I know so many of you tune in for. What else, Jesse, am I missing?
Got a technical session coming up.
Got another tech session?
Yeah, we'll be actually recording that tonight because it's on the schedule of the event here, so we'll record it tonight, but you guys will see it tomorrow. Looking forward to that one.
I'm going to go to a Women in Tech panel after this. There's a couple of those coming that I'm going to go to. I really enjoy those. I'll probably talk about that a little bit tomorrow as well.
Yep, so remember, go to the SolidWorks YouTube channel, set your notifications right there. You can subscribe. We'll be back around noon Central tomorrow, but once again, set that notification, and we will see you tomorrow.
See you tomorrow.